Hello, everyone. Welcome to the Premier Projects presentation of the Hamoye Internships, Spring 2023 cohort. My name is Mercy Opadoku, and my job here at Hamoye is to make sure you have a great experience. I'm joining you from Ibadan, Nigeria, and I'll be your host for this session. The mission of Hamoye is, and has always been, to develop an army of problem solvers through our internship-style training in data-centered careers. We pride ourselves as having been interns in the spring 2023 cohort of the Hamoye internship perform machine learning wonders with data sets from different domains, including sports, health, finances, and so on. Our interns got the chance to work in cross-functional teams on what we call premier projects. They have analyzed their assigned data sets, provided insights, as well as built and deployed models. They are now ready to share their findings with you. In a very special way, I'd like to welcome members of the different data science communities here present, Hamoye Fellows and Hamoye Internship alumni, and our incredible interns who have made it this far. A big congratulations to you for the grit and excellence you've displayed so far. I'd like to welcome our judges, Enyene Rudolph. Is a data engineer at the Hamoye AI Labs. She's an Hamoye Fellow, and she holds a Bachelor of Science education degree in mathematics. Her areas of expertise or interest include Python development, data analysis, and data engineering. The second judge for today would be Oakim Naimeka Edward. He is a data engineer with more than 3 years of experience of developing, training, and deploying models in domains like computer vision, natural language processing, NLP, and reinforcement learning. Both of our judges are alumni of the Hamoye Data Science internships and being former interns themselves with years of experience under their belts. They have a lot to give in advice, critiques, as they fastidiously examine every group's work. It's a session worth looking forward to. And now, without further ado, I will now hand over to my colleague, Christian, who will be taking us through the presentations and the rest of this session. Christian, you're welcome.
All right, thank you, Mercy. Thank you, everybody, for joining. Okay, just before we go into the presentations proper, please take note of the following. Each team will have only 5 minutes for their presentation. You'll be given a warning to round up at the 4 minutes, 30 seconds mark. That means when your time is almost getting up, that's 30 seconds to go, you'll be informed that you have 30 seconds. And also, if your team is not available at the allocated time, the team will be forfeited to the last on the queue. And when we get to that stage and you're still not available, we have to forfeit your presentation. Then also at the end of every presentation, we will hand over to our judges for their questions and comments. So feel free to use the comment sections for your comments and contributions. And finally, dear presenters, try your best to be concise and straight to the point. Remember, you have just 5 minutes. All right, so I hope you've gotten those information. So without any further ado, we'll call on the first team for their presentation. That will be team algorithm. Do we have Abdurakib or Motosho? Team algorithm. All right, your time starts now. We can't hear you. Can you unmute?
Can you hear me now? So the prayer is about the prediction
Yeah,
of
time has started.
customer personality analysis. So the goal here is This analysis and in-depth examination of the company's ideal customer. So by providing valuable insights that enhance understanding and facilitate product customization to meet needs users of various customer types. So by leveraging customer analysis, business can strategically tailor their products to specific customer segments. So the problem of receiving identifying distinct customer segments based on the characteristics of the data set that have been given, demographic, behavioral, psychological characteristics. Everything seems that developing targeted marketing campaigns or strategies that resonate with each segment. So the goal is to better understand the needs and preferences of customers and to develop market strategies that increase customer engagement and loyalty. So for the project, this is the approach is followed from the data collection, which was the CSV file that we downloaded from Cargo. Then we process data. This year we remove some null values from the data set because we had null columns. Then we move on to feature engineering. Feature engineering basically involves engineering new columns from the previous one. The aim of this is just to try to enhance performance of the model. Then from there we that's exploratory data analysis, which is to gain insight into each of the features in the data set here. So then we build data sets, then dimensionality reduction is the approach we use here. Because we have many features, so we did this just to visualize our data set using an dimensionality reduction. We made use of a statistical technique called principal component analysis here. So the aim here is just to visualize all our data sets after we broke it down into 2 or 3 features, so it will be easier to visualize it. Then we built our cluster algorithm. We use the k-means clustering algorithm here to the k-means clustering algorithm here for the model. Then cluster profiling. After this profiling of the cluster algorithm, then effect and interpretation. Then next one, this is an example of one of the videos. So this is the sigma puts in the correlation between variables in the data set. Then now after we remove some outliers in data set, so now we use another correlation method. We can see correlation between a feature such as income and total spend now 0.8, which is very high now. After we have removed the outliers. So data scaling here. So this is where we did dimensionality reduction. We can see the features from more than 13 features. We have broken it down to 3, and we can see the features in 3D format, which is easier here. Then up next, the cluster algorithm. So we make use of 3 different metrics to evaluate which are going to give us the optimal cluster of optimal number of clusters. So we made use of silhouette method, the CP method, and we also made use of the silhouette method, the Canopy Habans method, and the famous elbow. So after using this method here, then after making use of this method here, we found out that the optimal clusters we had for elbow was 5, silhouette and CH method was 2. So we are going to prioritize this silhouette and CH method because you can see that data points are relatively well separated from each other from other points outside. So it's just better that we are just going to make use of these 2 clusters since this is the majority of the 3 metrics we use. 2 of them are giving us the optimal number, which is 2. Then move on to cluster profiling. So these are just some of the visualizations we make. We use a volume plot here. So we use the scatter plot here. Use the box plot here. We make different types of plots here. Then the conclusion after we have profiled the clusters. So we finalize it. We just got the conclusion that because to increase acceptance, because we saw that there was a reluctance between customers to accept something, so to To rectify that, it will increase customer acceptance and boost participation rate. It is essential to tailor offers specifically to preference and needs of customers in cluster one. So implementing incentive programs too, because we saw that in cluster zero, we have people that are earning low and people that with the lower number of income. So to do that, to make them stay onto the business, if we implement incentive programs for repeated purchases, which will encourage continued engagement in business. And it's also worth knowing that the potential for growth in e-commerce selling, because we notice that most commerce customers they prefer to make their purchases at the store physically. So, and after that, we see that as an e-commerce selling, so most customers also prefer to buy online through the web. So there's a potential in the e-commerce selling because fewer customers currently make online selling, but it can change in the future. That's why the business is prioritizing improving website visibility to tap into this growth potential.
Your time is up, Abdulhakeem.
Okay.
Thank you very much for your presentation. And I'll call on the judge, Hakim. Do you have any comments for his presentation? Hakim, can you hear you clearly?
Hello?
Hear me now.
Yeah, we can hear you now.
All right. So Rakib, right?
Yeah.
Hello. All right. So tell me about this data set you used to do this modeling. What's the data set? Where is it from?
We got the data set from Cargo online.
Yes, I know. I want to know like yeah, so what's it about? Like what's the data set? Like you said you got the data set, but like what's it the data set? You said it's for customer segmentation. That's the problem
That's
statement
the
here.
problem.
So I want to know like this data set, what does it represent?
So the data set just
Hello?
represents. Hello, I can hear you.
Yeah.
I think it represents
Okay,
customers'
okay.
demographics, their income, their ID, their age.
Okay.
So it's just
Okay.
a
Their ID,
and
their age. Okay.
that is just true because it was launched in 2014 and sorry between 2014, I think 2013 and 2014. So it's just better. So we just assume that the data they collected was in January.
Okay. Okay. So you perform the segmentation and like what's this I don't really understand the conclusion though. You said to increase customer acceptance and boost it's essential to tailor campaign offers specific to the preferences and need of customers cluster one. Where's cluster one? You did not visualize the clusters
We
for
were
me
able
to
to like
see
because we had a limit
and
of slides we could present. So we couldn't put the whole data into sorry, the whole of the project into the slide because the maximum was we had a limit that we were able to present. So in cluster one, the profiling is just some community.
okay. Are you still there?
Yeah,
I can't see your screen. Okay, there's no need to change it. There's no right. I've gotten everything I need. All right.
like
Thank you.
it's just like the details, the whole work. Yeah. So this
Okay. Is this your is it that published this?
yeah, this is like the project documentation here. So I'm trying to use it. I'm not using it like anymore.
Okay.
Profiling with this.
All right.
This
Thank you. Thank you
cluster zero
very
and cluster
much.
one.
All right. You can send the link. You can send the link to the chats. Thank you.
Okay.
All right.
All right.
Thank
Thank you very
Yeah.
much, judges. You can stop sharing your screen now, Abdulhakeem. Okay, moving on to the next group. We have Team Anaconda. We have Coyote and Abdul Mujib Opatola, if I got that correctly.
Yes,
So,
yes.
okay, you can start sharing your screen now. All right, you have 5 minutes. Your time starts now.
Okay. Thank you very much. So my name is Abdulmujib Opatola from the Anaconda team. So the title of our project is Analyzing Automobile Recalls, Manufacturers, Components, and Safety Impact. So here's our problem statement. The main aim of this project is to analyze a data set containing information about automobile recalls, specifically focusing on different recall types such as vehicle tire, equipment, and child seat recalls, to provide insights into manufacturer components and recall types that have the most significant impact on public safety and potentially affect the highest number of individuals. Then we also aim to develop a machine learning model that can predict the corrective action based on various input features, facilitating proactive measures in addressing recalls and ensuring consumer protection. So here is our objectives. Identify the top 10 vehicle manufacturers with the highest number of recalls over the years. Determine the top 5 manufacturers associated with each recall type. Explore the top 10 reported components for each recall type. Calculate the average number of people potentially affected for each recall type. Determine the highest and lowest number of people are potentially affected for each recall type. Identify the components within the each recall type that have the highest and lowest number of people potentially affected. Determine the manufacturers with the highest and lowest number of people potentially affected within the each recall type. Then also to build a machine learning model to predict corrective actions variable using the manufacturer, subject, component, and recall type as input features. So about our data sets, the source of our data set is Kaggle, from Kaggle, and primarily from the National Highway Traffic Safety Administration in the US. So the agency is saddled with the responsibility of documenting recalls of automobiles. So the data set consists of 26,590 observations with 12 features. And here are the features: the reported dates, the ID, recall link, manufacturer subjects, components, manufacturer campaign number, recall type, potentially affected people, recall description, consequence summary, and corrective action. So based on our aims and objectives, we remove the unwanted columns: reports received dates, the HDSC ID, recall link, the campaign number, and recall description columns were removed from the data set. Then we are now left with the manufacturer, subject, components, recall type, potentially affected, consequence summary, and corrective action columns. So we discovered that there are missing values there are 42 missing values in the potentially affected column. So, and since it was about 0.15% of the entire data set, we decided to remove it from the entire data set. So then we go on with our data analysis and visualization. So our first question is to find the top 10 vehicle manufacturers with the highest recalls over the years. And this is represented by this bar chart, and we can see it here. So the top 10 vehicle manufacturers with the highest number of recalls are dominated by major automobile companies over the years, such as General Motors, Ford Motor Company, and Chrysler. So General Motors LLC has the highest number of recalls, followed closely by Ford Motor Company and Chrysler. So then just like I said, we grouped our data sets based on recall type, because we are analyzing based on each recall type. So We have 4 recall types. We have the vehicle, tire, equipment, and child seats that were reported. So for the vehicle recalls, what are the top 5 manufacturers with the highest number of vehicle recalls? General Motors, Ford Motor Company, Chrysler, then Volkswagen Group of America, BMW. So then we also find 10 components of vehicle recalls that were also reported. So the
You have
most
30 seconds more.
So the most frequently reported components of vehicle recalls are this equipment. Then we found the average number of people affected by vehicle recalls, highest number of people affected by vehicle recalls, and manufacturer with the highest potential affected counts, Ford Motor Company, then Honda. So then we did the same for tire recalls also, and we found that Cooper and Rubber Company, Uniroyal Company, and Firestone are among the top manufacturers associated with tire recall types. Then the distribution of the components for both tire recall type and child seat recall type. You see that tires and child seats are the common components, of course. Then the top manufacturers for child seat recalls also Even Flow Company and Century Products and Dura Juvenile are the major manufacturers. Then you also find the average number of people affected, then the manufacturer with the highest number of potential affected count and component to the highest number of and the lowest number of potential people affected. Then for the last record type equipment, we also did the same thing. And here's our observations, Cummins, Meritor, and Avi Meritor Automotive.
I'm sorry, your time is up. I gave you some extra seconds there. So thank you for that presentation. The Judge Ayene, do you have any questions for the team? Ayene, are you there? Okay, if you can hear me, Ohakim, do you have any questions for the team?
Okay, yeah. You said something about, sorry, what's his name? Abdul Mujid, Abu Mujib. You said something about machine learning. Sorry, machine learning model. Where is the model? I don't see any model. You just did like some analysis.
Yes,
Hello?
I couldn't reach that part before my time lapsed. So what we typically did was trying to predict corrective action, to predict the corrective action for all those recalls based on the inputs. And the inputs we looked into are the based on the manufacturer, the subject, that the reason for the recall, then the components, and also the recall type. Those are our inputs that we used. Then, and since it is categorical data, we have different classes. So we decided to use multinomial logistic regression and decision tree. Then,
Okay.
yeah. So the data set was quite large. So we did stratified sampling based on.
Wait, sorry, wait.
Okay.
Wow, your presentation is quite long. It's still going on. Still on.
Yeah.
Okay,
So
sorry. So what's the corrective? You said the predicting a variable corrective action. Yeah.
corrective action. Yes.
What's that? Can you explain that to me? What does that
corrective
mean?
corrective action is that, okay, after they have produced all those automobiles and they discover that, okay,
Yeah.
that they made a recall based on a particular component of the automobile. So what is the corrective
Okay.
action to correct that? So we now try to build a model that can be able to predict that based on the information, maybe based on the components of the recalls that actually had problem,
Okay.
then the reason for the recall. So that's what we actually did.
Okay.
And
See, I can see a lot of categorical features and
yes,
in
yes,
the
they were all
okay,
categorical features except the potential
there were a
uh,
lot.
of people. So we use TFID vectorizer and
TFIDF,
yes,
TFIDF,
and one hot
uh,
encoding
one
to
hot. Okay,
yeah to preprocess our
okay.
data.
To processes
So
the categorical data now.
yes, yes, yes.
So
Then
what was the metric you used?
yes, we used recall score and precision score, given that the our
Okay, okay.
predicting
Yeah,
corrective
it's
actions
imbalance.
have
It's imbalance.
yes imbalanced classes, a lot of classes, so we had to use that. Although
Okay.
in our code we also look for test accuracy, but of course that one is not relevant since we have imbalanced
Yeah,
classes.
yeah, I get that.
So
All right. So this corrective, so how does it, your problem statement is high risk of automobile recall in a country, yeah? So
yeah,
like now that you predicted that, how does that like
uh,
determine
the
the
public
risk?
safety. Yeah, actually,
Yeah.
the main aim of our analysis is kind of
Okay.
to
To provide
yeah
insights.
the to predict the corrective action to facilitate proactive measures is one major part of the aim, and to the how
Okay.
the manufacturers components and record types affect our how is it significant on public safety is another aim. So that was the essence of the own analysis I was presenting the other time,
Okay.
to
Okay.
find okay, for this particular company we can say that they have so many number of records over the years, and we may not be able to
Oh,
trust their product, their automobiles products in terms of public safety
okay.
and stuff like that.
Okay. Okay. That's okay. That's okay. Thank you very much. Thank you.
Thank you.
Yeah.
All right. Thank you, judges. Thank you for that presentation. You can stop sharing your screen now. Moving
All
on
right,
to the
thank you
next.
very much.
Yeah. Moving on to the next team, AWS. We have Toby Jane and Evia Basili. Are you here?
Yes.
Okay. So you can start sharing your screen now.
So, is my screen visible? Hello. Am I audible and my screen is visible?
Yeah, you're audible. Your screen, you can see your screen. Your time has started.
Hello. All right. Okay. Like it's good evening here in India. So the topic of our presentation, like the topic for AWS group presentation, is Tesla stock price prediction. So this is my theme. Like I am Surbhi Jain, who is presenting, and with me I have another presenter who's also the project lead. So there have been bunch of active members who have really worked hard and contributed towards the success of the project. So moving forward, so so what our project intend to solve is the problem, and what is that problem? So stock market is characterized as dynamic and volatile, which makes it unpredictable. This is a challenging task, the factors and qualitative factors. Thus, to maximize the profit and stock merchants to make best decisions, techniques to predict values of stock in advance by analyzing the trend over the past few years. That is analyzing the historical data could prove to be highly useful for stock market movements. So, before like uh, like what are the pre-existing learning technology. So like in 1927 who came up with the AR model, autoregressive model, and in moving average model, AR MA model. So basically these are the classical models to predict the time series data. So what is our approach? um, So what is our approach basically? So with the recent rapid development and extensive use of machine learning and neural networks, the combination with the time series and data mining has become a very very lucrative and hot topic. And based on historical stock data, we have been predicting the future stock prices using the supervised machine learning algorithms. So precisely, we have use linear regression, decision tree, and k nearest neighbor. So we have done a comparative analysis of all these three models and came up with the best model to predict the future stock prices. So the first step is like data preparation, which is further subdivided. And our data was hosted as on the Yahoo Finance website. So the data was comprising of 3261 records with 7 features, where 6 were the numeric features and 1 was object type feature. And then after acquiring the data by simply downloading it in CSV file format, we imported the data into the Python software for further analysis. Then we did the pre-processing. So we precisely used the pandas library to check for null values, to find out duplicate columns, and to fix the inappropriate data types of the features. So here normalization was also performed uh, using the min max scalar function. And then then we explored the data. So in exploration we basically came up with the visualization using the matplotlib and seaborn libraries, and created different and created various pair plots, line plots, histograms, heat maps to understand the relationship between features and identify any patterns over the time. So so further, so last year was the data preparation, which I training. So we basically
You
trained
have,
all.
sorry, you have 30 seconds more.
Okay, so we trained the model using using the two features, close and target, like open and target, and then there was a target variable called close. Then we evaluated the model, and then we tested the model using the unseen variables. And the nearest regression model came up with the 99.71 accuracy. And so basically, the future scope of our project use more variables, more feature variables as the independent variables in order to find out the dependent variable, which was the close price or the stock price. And we can also use the neural network models like long short term memory in order to come up with more efficient models to predict the stock prices. Yeah, thank you.
All right. Thank you very much for the presentation. Judges, Ayene, you have questions for the team?
Okay. Thank you very much for that presentation. It's quite straight to the point. So in your slide 6, right, you can go to slide 6 where you talk about the data preparation. Am I audible? Can you hear me?
Yes, I can hear you.
Okay. So where you talk about data preparation. Okay, so you talked about identifying and understanding some relationships between the features.
Could you please repeat?
So you talked about identifying some relationships between the features.
Hello.
Yeah.
Anybody? Can you hear?
Yes, we can hear you. Hakim.
Hello.
Christian, please, can you confirm that I'm audible? I think she's having
Yeah,
issues
we can hear
hearing.
you. I think she has a network connection issue. And there are meant to be 2 presenters. Where is our colleague? Can you take over from her?
Okay, good afternoon. Can
All
you
right.
guys hear me?
Yeah, we can hear
Yeah,
you
we
clearly.
can hear you.
My name
Okay,
is
so
Elabasi. Okay, sorry. Go ahead.
all right, no, that's fine. Okay, so I basically want to understand the relationships and the relationships between the features and some of the patterns that you identified. You did mention it, but you didn't show it. So can you shed more light on that?
Okay, the heat map that shows the relationship between the variables is in our technical report. It's not actually in the slide. So the names of the variables are the open, close, the high, the low, and the adjacent close. The close and the adjacent close variables are very similar in nature. So I don't think there's any point explaining that. The close is the variable that tells the digits at what the market closed. The open is the variable that tells at what digits the market opens. The high and low are the highest and lowest trade points. I think I can call it that. Highest trade points during the time the market is open. And then the volume is the amount of shares or the amount sold during the time the market is open. Hello?
Yeah, I can hear you.
Okay, yeah. So these are just the variables that are present in the data set.
So what particular patterns over time did you identify?
Okay, the high, the low, and okay, yeah, the adjacent I already mentioned, the adjacent close and the close variables are very similar in nature. They are almost as if duplicated. So we had to remove that one from the data set. Then the open, the close, the high, these 3 had multicollinearity. They are the relationship between them, the correlation between them was very high, sometimes almost as close as 1, that's 0.99 and above. So these are just the main patterns we identified.
Okay, fair enough. And then so who is this model useful to? Is it deployed anywhere? Can I use it to predict anything?
Oh, yes.
Do I have access to it? Okay. Okay,
The
I think
model,
you should share that. Did you share that in your article?
okay, no.
Yeah, I think that's important, right? Because at the end of the day, the goal is to be able to have something that people can use to.
Yes.
Okay. All right. All the same, it's a good project. Well done.
Thank you.
Thank you, Yana. Okay. Thank you, AWS. You can stop sharing screen. All right, moving on to the next team. We have Team Beanstalk. We have Mujib and Kadasami. Team Beanstalk.
Good afternoon, everyone.
Yeah, you can start sharing screen now.
This is Mujib. Okay. Thank you. No. All right. Okay. Can I start?
Yeah, go ahead.
Okay. Good afternoon, everyone. This is a presentation for the
Hold on, we
team.
can't see your screen yet. You have to share your screen. Can't see it again.
Okay, sorry. Oh.
If you're not
Okay,
ready,
I've shared it.
move on.
I've shared it now. Can you see my screen?
Yeah, I can see your time has started.
Okay. Good afternoon, everyone. My name is Mujib Shenbare. I'm presenting for the Beanstalk team. All right, our team. Our project lead is Shenbare Mujib. Assistant project lead, Kalista DK, query analyst, Ihoma Adoba. And we also have other team members that fully participated to ensure the successful completion of this project. Now, onto our problem statement. So we are to predict the total number of daily demand orders for a Brazilian logistics company. Our task is to build a statistical or machine learning model that can accurately predict the total number of orders on a daily basis. Now, our approach. So we carried out exploratory data analysis for the data set, data manipulation and preprocessing, model fitting on the given data set, and evaluation of the best fit models. Then dataset description. This dataset was gotten from an online UCI repository. It is a real database of a Brazilian logistics company collected for 60 days. The dataset has 12 predictive variables and a target variable, which is the total number of orders for daily treatment. We carried out ED, exploration data analysis, to confirm if there are any missing values or any duplicate values in our data set. We also carried out univariate statistical analysis, such as the mean, standard deviation, minimum value, maximum value for each of the columns. And on our visualizations, the box plot of visualization here confirmed that there are a few features in our data set that have outliers. Also, we plotted histogram to show the distribution of each of our data sets. And we also plotted bar chart and pie chart to further understand our data and to compare the different frequencies between our features in our data set. Then lastly, we plotted a heat map correlation plot, a correlation coefficient heat map, showing the linear relationship between the predictive features and also with the target variable. Then onto the data preparation stage, we carried out feature selection, whereby we removed features that have little or no predictive power in our data set, and we retained the features that have high predictive features in our data set. Having done that, we were able to remove about 6 columns from our data set, retaining 7 features that are useful for our prediction purpose. And we standardized our data set for validation purposes, and we did 80% train set and 20% test set for our model. Then we now applied different regression models, because this is a predictive challenge. So we applied different regression models on our data set to gauge their performances and compare them. From the model scoreboard that we got, we were able generally to discover that the train score was slightly significantly higher than the test score across all performance evaluation metric, the R-squared, that's the adjusted coefficient of determination, the mean squared errors. So across all those performance metrics, we discovered that there was a little bit of significantly higher train score than that of the test score, probably hinting towards a probably overwritten or high model complexity. So what we did was to combat that is to apply PCA, that's principal component analysis, to remove noise from the data and also improve the accuracy of our models. Having transformed our data set with PCA, we again evaluated the performances of all these models against our data set. And from what we saw a significant improvement in the difference between the train and test score. It was minimalized, it was reduced greatly. And from the results, ridge regression, linear regression, orthogonal matching pursuit regression respectively demonstrated the best performances among all these models. Linear regression had a test score of 0.971, ridge regression was 0.969, and orthogonal matching pursuit was 0.971. And there was a minimal difference between the train to our test score, leading to a good generalization of our models. Then to summarize, our project was carried out by the team, and the team members successfully participated in the project, ensuring that the project was completed at the allotted time. Again, to summarize what the activities that we carried out, we did EDAs on our data set. We did feature selection processes on our data set to select the features that have high predictive importance, predictive power, and remove the ones that have little or no predictive value. Then we use different regression models on our pre-processed data, and we discovered that linear regression, regression, and orthogonal matching pursuit CV, that's the cross-validated version of orthogonal matching pursuit, demonstrated the best performances. And this was confirmed by this chart plot here, showing a minimal difference between the predicted target variable and the actual target variable. Our recommendation may be that probably we would like that we have a data set with larger number of variables so that we can experiment more and with higher number of observations to improve the accuracy furthermore. So that is the end of the presentation for the Beanstalk team for this model building challenge. Thank you.
All right. Thank you very much. That was a nice and fast presentation. ANA, you have any questions for the team?
Yes, Beanstalk, I appreciate the flow with which your presentation went, right? I appreciate the storytelling. So my question for you is, what were the challenges you faced with this project?
Yeah, the challenges that we faced, first of all, was like trying to get different people together, across different time zones. We have somebody from Ethiopia, somebody from Kenya, somebody from India, different time zones, trying to get them together to work, and we succeeded. Then another challenge that we faced was that the variables that we had they were 12, and some of the variables were actually very linear, like they were very similar. Some of them are similar. So we had to imagine we had to remove like 6 variables from 13 variables. And we would like that we have more variables so that we can do more and come up with different ideas so that we can improve the model building challenge, the model building accuracy for all our models. So that we can now see, okay, this is the best model. Say for unseen data that has not been used before, we can now say confidently that, okay, fine, we're confident that these our models can do very well with unseen data. So those are the 2 basic challenges that we had for this project.
Okay, so as a follow-up, how did you get your data again?
Yes, let me scroll back. So we got from this online repository. The link is here if you want to take a look. So let me scroll. So we got directly from this archive ics.uci.edu link. So it's a daily demand forecast of that data set for a Brazilian logistic company collected over 60 days.
Okay, I'm going to assume that you really couldn't find other data sets that might have helped out with the issue you mentioned, right? But then
okay.
I was hoping that one of the challenges you would mention is the fact that your data set was small. Yeah, I noticed it has only about 60 rows. So my question to you on that is, how did what measures did you put in place to avoid overfitting with the model, considering you had like a small data set?
Okay. First, to address your first issue, I actually mentioned that one of the challenges that we had was that the data set is small, like number of variables. I actually mentioned, if you heard me, I mentioned. So it prevented us from experimenting more with our data set, but we have to use what we were given. To prevent overfitting, so we used PCA. What PCA does is that, given that our data set is small, it helps us to transform our data set into the direction of maximal variation. So that allows for more generalization. When you transform your data set to the direction of maximum variation, so you have like allowances to play around and to prevent overfitting. And again, if you look at some of the models that we use, models like ridge regression, they are regressions that were naturally built for generalization to reduce complexity, like ridge regression that use like L1 num to reduce overfitting. Ridge regression use L2 num. Lasso regression use L1 num. These are regression models that we are naturally built to reduce complexity of the model. And you will see that they are the ones whereby we have the best performances. So that was what we did.
All right. Okay, that's fine. That'll be all from me.
Thank you.
All right. Thank you very much, Ayane. You can stop sharing your screen. Moving on to the next team to present. We have Team Collab. We have Abdul and Hajara. Are you here? Abdul and Hajara.
Hajara is here.
All right. You can start sharing your screen now.
Thank you.
We can't see your screen yet. Your time has started. Well, if you're not ready, we're moving on to the next team to present.
Okay, had a
All
little
right.
challenge. Can you see my screen now?
Yeah, I can see it. You can go on.
Good afternoon. Good afternoon, everyone. My name is Hajar Adamu. I am the presenter for Team Collab. Today, we present our machine learning group project on the prediction of global terrorist attacks. Our primary objective is to analyze global. Our primary objective is to analyze global terrorism trends and determine factors influencing attack success or failure. We aim to build a predictive model that forecasts the success or failure of a terrorist attack. So our goal is to predict the success or failure of potential terrorist attacks. We worked with the Global Terrorism Database containing global terrorist attacks activities from 1970 to 2017. The dataset has 135 features and 181,691 observations, including numerical and categorical variables. Our target variable is the success feature, indicating whether an attack was successful, 1 or not, 0. We carried out various exploratory analyses to understand the trends of attacks over time, and we were able to answer the following questions. We explored regions, countries, and cities with the highest number of terrorist attacks. And this graph shows that the Middle East and North Africa region have the highest number of attacks over the years, while Iraq has the highest rates of terrorist attacks by country. From this graph, you can be seen that the Taliban terrorist group had the majority of the successful attacks, followed closely by the ISIL terrorist group. Majority of the attacks over the years have been targeted at private citizens and property, followed by military. And the most common type of attack is bombing explosion. This analysis shows the percentage of successful attacks carried out within 24 hours. Time series analysis shows an increase in successful attacks in South Asia and the Middle East and North Africa from 2000 to 2017. So we selected the SGB classifier model for
our we use the base N encoder with a base of 2 for encoding. The target imbalance was addressed by comparing results with and without the synthetic minority oversampling technique for nominal, that's smoothing. The SGB classifier performed best, achieving high accuracy and ROC coverage scores. Parameter tuning and pipeline creation improved the model's performance. I would share the model deployments.
We have 30 seconds more.
So this is our model to get a prediction for terrorist attack by Boko Haram in the city, in the Chibok city of Nigeria. The probability of success is 1. Our analysis provided several insights into global terrorism trends. And this is the deployment of the model.
Okay, your time is up, Ajara. Time is up. Thank you for your presentation. Hakim, you have questions for the team? We can't hear you clearly. Okay.
Like, hello. Hello, can you hear me?
Yeah, you're not audible enough. It's quite low.
Supposed to be audible enough. So you can't hear me clearly now?
Yeah, I can hear you now. I can hear you now.
Okay, I was saying like, who is sharing her screen? Like, I wanted to ask, she said the program city was like prediction of attacks by terrorist groups, but I don't think she followed that along the way, because I ended up predicting about the success and the failure of a terrorist attack, not like, is it forecasting? Was that what it was supposed to be? I just want to get clarity.
Yes, our aim was to build a predictive model that forecasts the success or failure of terrorist attack.
Okay, the success or failure, not just
Yes.
like to forecast like if there will be a terrorist attack. Okay. Okay. All right. So you didn't enlighten me more on like the modeling phase. You just said you use XG Boost. Did you try out other models? How? Are you still there?
Please, can you say that again? I'm here.
Well, there's an echo. I said, you didn't talk much about the forecasting. Sorry, the modeling, the features you used. You just went straight to like use an XGBoost classifier, and the features you used. I don't think you elaborated much on that.
Okay, so for the modeling, we analyze the effects of the algorithms with the smoothing, and then we compared them with the results of not applying the technique.
Okay, let's move on to the next group, please. I didn't get it. Like as if you echoing. I didn't get that clearly.
Can you hear me better now?
I will look at your slides.
Okay.
I will look at your slides. All right. Thank you. Thank you.
All right. Thank you very much, Joaquin. Moving on to the next team, we have team GitHub. Resume. Chidera and David, are you here? Team GitHub.
Yeah.
Yeah. Yeah, take it out. The floor is yours. You can start sharing.
Okay.
You.
Good day,
your time starts now. Go on.
Good day, everyone. My name is Chidera Ibe, representing Team GitHub. The project topic is early prediction of student performance in higher education. Obtaining an academic degree possesses significant challenges for students worldwide. What are the risk factors affecting their performance? What optimal approach is needed to address this issue? This project aims to address these concerns by investigating the optimal approach for accurately predicting student performance at the earliest stage of their academic journey. Our problem approach is we aim to solve this by using machine learning perspective, which is classification predictive models. The dataset was obtained from UCL Machine Learning Repository. It contains 4,424 rows and 37 columns. Data wrangling was not done as the data was pre-processed with no missing value. The data which was encoded with numbers underwent meticulous categorization. The exploration was carried out in 7 categories, which aided a comprehensive understanding of the distribution pattern relative to the target variable, graduates, enrolled, and dropouts. The feature categorization helped to determine major variables needed for the model building, such as enrollment, application, financial, and demographic factor. This exploration correlated with the feature engineering insights as curricular units, as seen in the heat map here, exhibited strong positive relationship, and students who meet the first phase general constituent, as shown in the application mode bar chart here, have high graduate rates, while students over 23 years old have high dropout rates. My colleague here will give further insights on the project.
For the features engineering, we started out by checking for the data distribution in the target variable, which revealed a very high class imbalance among the class level. Then we checked for multicollinearity and discovered that it existed among the predictors. This prompted us to do feature importance using permutation feature importance techniques. And these are the results we obtained from the permutation feature importance technique. And we discovered that academic performance in both the first and second semester, together with age and tuition fees, are very, very important. So these were selected and used for the model development. For the model development, we carried out a class stratification technique to split the data into train and test set. And we trained 5 models at this level, at data level and algorithm level, considering the imbalances in the data. After training baseline models, we did cross-validation and did optimization before evaluating on the test set. So here's is a classification report of all the models we have. And we discovered that the accuracy and the F1 score are almost equal, showing that there was no form of bias, and the models perform optimally, with the highest one being 75% smooth plus RF and SVC, while other models range from 71% to 72%. We also check for the performances in each of the class label in the target future. And we discovered that we have 3 best performing models to predict each of these classes. And here is a confusion matrix showing the ability of our models to generalize. So here's a sneak peek of our model in production. And we can see how the model is performing. We use HTML and CSS at the front end and Flags at the back end to deploy it on Heroku. So this is what we have for the model deployment. So it's predicted dropout for this particular data we inserted. This is the model. We are just inputting the input. And it's protect graduate class. So summary, we relied on the F1 score matrix, and the earliest stage at which student risks of dropouts can be predicted is the first semester, although we consider the first academic session, that is first and second semester, due to its more predictive accuracy. Limitation faced in this project is the imbalanced nature of the data. And by this, we highly recommend investigating techniques that aim to enhance model performance to further advance their effectiveness, accuracy, while being fair, updatable, and explainable. Thank you.
Okay, thank you very much for your presentation. Ayene, you have a question for the team?
Yes, that's a nice presentation. My question is, what did you do to address, you mentioned the imbalance?
Okay, what we did to address the imbalance, we use, we consider this at a data level and algorithm level. So for the data level, we applied what we call SMOTE, synthetic minority oversampling technique, on the data set. So this works by creating instances of the minority class in the future space by using the K nearest neighbor. So we also use another variant of the SMOTE from the eBlend library. We use the SVM SMOTE that uses the support vector machine instead of the K nearest neighbor to create those instances. So this was applied on the random forest classifier, and the SVM SMOTE was also addressed on the random forest classifier. Then for the algorithm level, we used models or algorithms that have an inbuilt configuration to undo imbalances. And these are the balanced random forest classifier and the easy assemble classifier. And also for the class imbalance too, we also use a technique called the class stratification using the stratified shuffle split technique. So it will create a form of strata that are homogeneous, containing equal proportion of the data in both the training and test sets to avoid any form of bias. So that was how we handle the balance in our data.
This work that you've done, what room for further improvements is there?
For further improvement, due to the imbalances in our data, that's why we recommended that the need to investigate techniques to enhance model performance, because this our project relied on 3 classification methods. In the class label, we have 3 classification. We have graduates, enrolled, and dropouts. So if we can have a technique such as probably a binary classification, it could possibly improve the model performance. As also, we can use something like a one-shot classification technique to improve model performance. But because of our projects dealing with a 3 classification, it's and very, very high imbalances, those are the techniques that can be used to improve this model performance. And also, when trying to improve the performances, we should try to make it updatable, because for this kind of projects, more information, there's shifts in data distribution. So the models that will be used must be updatable and explainable to the end users.
Okay. That'll be all from my end, actually.
Okay,
So,
thank you.
Thank you very much. This is a lovely project. Well done.
Thank you.
All right, thank you very much, Elena, for those remarks. You can stop sharing your screen. On to the next team, we have Team Hadu. We have Favor and Kazim. Are you on the call?
Favor is here.
All right, you can start sharing your screen now.
Okay.
Your time starts now.
Good day, everyone. My name is Favor Sukat, and alongside my co-presenter, Mr. Kazim, we'll be taking you through our project for the Hadoop Group. Our topic is International Football Match Result Forecasting with Machine Learning. These are the names of our representatives and our active team members. So the problems that we discovered during this project, which we try to solve, are lack of reliable predicting methods, inefficient use of available data, limited accessibility of predictions, and user demand for reliable insights. So there are already existing solutions, some of which includes expert opinions, crowdsourced predictions, betting odds, and online prediction platforms, but they are limited in terms of accuracy, coverage of factors, or accessibility. Now, our project aims to solve all of that. The aim is to develop a machine learning-based system that accurately predicts football match outcomes, leveraging on historical data and advanced analytical techniques to predict future matches. And this is the flow of our project. First, we do the data sourcing, then data preparation, then EDA, and finally, we do a model training, evaluation, and validation. Our data set was sourced from Kaggle, and it was named results as a CSV file. It had 44,557 rows and 9 columns. Our data set was clean, there was no null value, and there were no duplicates. At this point, I'll be handing over to Mr. Kazim to take the presentation.
Okay, good afternoon, everyone. So in course of doing data wrangling, exploration and processing, we actually discovered that there were outliers like in our data sets. Then aside from that, we created a target variable, which was not in a data set. Then we had to drop columns that were not really important to our modeling and our machine learning tasks. Then also we did encoding using one-hot encoding to encode the categorical data. Next. So after that, we did exploratory data analysis by showing the relationship that exists between the variables. So here is an EDA representing the top 10 home teams and a weighting based on the number of matches played. Aside from that, we also have other EDA graphs showing the relationship between our variables. Next. So we also have here, this is a bivariate analysis using the away score and the home score. Then we also did multivariate analysis also. Next. So this is a multivariate graph showing, so the multivariate graph actually showed the relationship between the home score, the away score, and our results. Then after we did all the necessary data wrangling and the other processes, we developed a machine learning model using KNN, random forest, and XGBoost. So why doing that? We discovered that KNN performed poorly on the data sets, while random forest performed very well, but the one that performed the most is our XGBoost, which we later chose as our algorithm. So when we tested the XGBoost on our data sets, we actually realized that the XGBoost model gave us 99% accuracy. Next. So there's a confusion matrix showing the prediction of the true and the predicted values. And from the confusion matrix, we can actually see that we only have one class that was misclassified at the end of the day. So after the whole process, our conclusion.
Sorry, you have 30 seconds more.
So during the whole process, our conclusion is that while we're doing the machine learning tasks, we discovered that the outliers were really much. So we had to keep the outliers. And aside from that, it is normal in a football match to have scores that are very high. So that's the more reason why we had to keep the outliers. Thank you.
All right, thank you for your presentation. Hakim, you have a question for the team?
Good one. A favor, I want to ask, like, so are you trying to say like you have 100% accuracy in predicting like football match results or forecasting football match results? Can you hear me? Hello? Hello, can you
Yes,
hear
we can hear you.
So where's the presenter?
We're here.
So I was asking, like, so you say that you have 99% accuracy in forecasting international football matches.
So what we did was that on the validation data that we used, we had 100% just to choose the algorithm that we would later choose. So, and from there we have 47 for KNN, 99 for random forest.
Yeah,
and
yeah. I get that. I saw that.
So and when we later,
So I want to ask, what features did you use?
What did you say?
What features did you use?
For the home team, we have away score for the away team. Then we have a result, which is the result column, which is our target.
So I just want to ask, if you want to forecast a match, will you have known the away and home score?
I didn't get that.
I want, like, if you want to forecast a match, will you have known the away and home score? The Do you get my question?
Yeah. I think I get. In predicting football matches, I think it is based on historical data. So based on the past results between the two teams, that is what will determine what.
Okay, based on the past results.
Yeah, sure.
Oh, just the home and away. Okay. All right. I would like to see your slides. Thank you very much. I will see how it works. Thank you.
Thank you.
All right. Thank you very much, Hakim. Moving on to the next group, we have Team Jupiter. We have Emmanuel and Jimo. Emmanuel and Jimo, are you there?
Yes, we are here.
All right, you can start sharing your screen now. If you're having difficulty sharing your screen, we've moved on to the last to present if you're not ready. Emmanuel and Jimo. Okay, I guess you're having technical issues. We move on to the next team. You have to present last. Your time has already started. You have less than 4 minutes more. Kindly unmute, we can hear you.
Hello, good afternoon. This is Team Jupiter. I'll be presenting on the 120 years of Olympic data analysis. Next slide, please.
Angie, your time is already counting.
Can you hear me?
Yes, we can hear you.
Okay, so I'll be presenting on 120 years of Olympic data analysis. So I am Emmanuel Matuzaye, and my second presenter is Jimo, but he's currently having network issues. Sorry about that. So our problem statement, we basically spent the time analyzing the artist data to develop a predictive model. And the aim was to sort of develop and understand the factors that contribute to an athlete's success in trying to get a medal in the Olympic Games. And so we're trying to sort of develop a model based on characteristics and performance. So for the solutions, there are various data scientists that have engaged in numerous studies using approaches of identifying patterns to make predictions. So there are existing solutions using machine learning algorithms to predict these Olympic medal winners. And these solutions usually consider factors like past performances, demographics, and other relevant variables. So our approach includes data sourcing, description, processing, exploratory data analysis, the training, evaluation, and then the tuning, and then the prediction and model validation to see if our model actually works. And so this basically details our data description, where we talk about we split the data sets, identify the key features, handled missing data, sort of data integration, as well as exploration, in the sense that we rank the top 10 countries with most medals, top 20 with most gold medals, as well as the distribution of the age, weight, and height. And for our model prediction, we end up going with the decision tree. Decision tree algorithm. This is the fact that it had a low MAE and RMSE, which is basically a mean square error, which basically means that it was had a higher accuracy compared to other algorithms, while also having a strong R2 squared measure with its high correlation or correlation of determination. And so we try to then leverage this model by comparing with the actual and predicted value to sort of get a sense of if our models were actually accurate. As you can see with the metrics, they are actually very similar for both actual and predicted value, meaning that our model actually worked in real time. And so to summarize, our observation was that we were able to identify certain tendencies and distributions among age, weight, and height across all athletes' performances. That was one. We also were able to analyze Olympic athletes' data and then sort of figure out the insights and performances based on demographics as well as countries. although we had various challenges, which included the fact that we had to do extensive data cleaning due to missing data or data being infinite. We also had limited availability of other variables that could help provide access to data, as well as fields and also the issue of the complexity of determining Olympic medalists, as some Olympic athletes win more medals than others, as well as trying to measure
seconds more.
As well as also trying to measure other factors that could contribute to an athlete's success. For the recommendation, which was where we felt would be needed to make data even better, to also make better predictions, we said that we would have to incorporate variables like athletes training regimes and performances qualifying events, historical records, which could help improve the accuracy. We also would have preferred to use advanced machine learning algorithm techniques like deep learning to help create an even better predictive model, as well as also trying to quantify and document the impact of socio-economic factors, cultural influences, and political dynamics of different athletes based on different regions that could affect their performance. So even make a much more deeper understanding of the games. And that's all. Thank you.
Okay, thank you for that fast presentation. Ian, you have any question for the team?
The NOC in your future represent?
Hello?
Can you hear me?
Yes, I can hear you.
Okay, the NOC in your features, right? What does it represent?
Name of country.
Okay, all right.
Yeah.
Okay, so what imputation techniques did you employ? What did you try out and what did you finally settle on?
So for the imputation techniques, so like I mentioned, there were issues with the data. So certain athletes, for example, had missing heights, weights, and whatnot. And so we had to do things like using the median, using the mean, sort of represent this data, as well as also there were also like NaN, so missing variables, missing numbers. So we also had to fill it with 0 and whatnot. And so depending on the data set, we had to also create a separate table, for example, to sort of convert medals into ones and zeros, so as we could easily document how many people actually had gold medals and silver combined total from the population. So, and then we also try to understand the data by ranking countries.
Okay, hello?
Medals, the type of things we try to do.
Okay, so you said you tried to use the mean, right, and the median for that. So did you do that based on the gender or what exactly? How did you go about that exactly?
So different sports have different age distribution. So that's why I said we first try to analyze the age distribution of certain sports, and then we sort of classify based on that.
Okay, you did it based on the age distribution. Okay.
Yes, age, weight, and height distribution. So we use lots of data to help clean that all up.
You said age, height, and what else?
Yeah, we use age, height, and weight to sort of make a prediction on whether that could affect an artist's performance.
Okay, yes, I can hear you, but I'm particularly asking about the data imputation technique you employed, right?
Yes.
What considerations did you make, like in filling out? You said you used median, but like, did you make any other consideration? Did you take any other thing into consideration apart from just the median?
Yes, so different sports had different heights. So basketballers, for example, had higher height values than, let's say, people in athletics. So we tried to also account for that.
So and the gender, right?
And gender as well. Gender, obviously, the men tend to be slightly to be a bit much higher than the women as well. So we tried to do all that in our competition.
Okay, I mean that's seems like a well done project. So that's all from me.
Thank you.
All right, thank you very much, Ayana. Moving on to the next team, we have Team Keras. Abel and Gloria, are you here? Team Keras.
Yes, we are here.
All right, you can start sharing your screen now. Time starts now.
Good afternoon, everybody. I'm Onyechi Gloria. My co-presenter is Abel Beckel. The project we worked on is chickenpox case count prediction. Chickenpox is a very contagious illness that is widely spread, and we are making a prediction based on the Hungarian National Epidemiological Center that collects daily counts of chickenpox cases to monitor the spread of the disease. The problem statement for this project is to gain insights into its prevalence and its strength and potential factors contributing to its transmission. There are already existing solutions for this problem, which is vaccination, getting it, antiviral medications. The approach for this study seeks to learn the patterns that define how chickenpox spreads in Hungary, and also to develop a mechanism to control its spread. The dataset description, it is a spatial temporal dataset of weekly chickenpox cases from Hungary, which consists of a county level adjacency metrics and time series of the county level reported cases between 2005 and 2015. It was retrieved from UCI machine learning repository. So at this point, I will have to hand over to my co-presenter, Abel.
Okay, thank you, Gloria. So on the data, we did the data collection, transformation, and visualization. We used Python to render the data, checked for missing and duplicate values. We created a capital count column, and we univariate and bivariate analysis was performed. So next slide. Next, Gloria. So upon the discovery during the observation, we noticed that Budapest has the highest case count, which contributes about 30% of the national tally, and Zada being the least. Next slide. So in the weekly case count, still Budapest stands the highest with a value of 101 cases weekly, and followed by Pest and Boscher. So after noticing these observations, next slide, we were able to see that there was a total of 53,413 cases in 2005 and about 30,300 cases in 2014. This represents about a 3.03% decline. Next slide. Next. So we try to visualize the data as much as possible. So we noticed that there is a peak period in March and May, and there is an aspect of seasonality whereby the case count starts to decline around June of every year. Next slide. So when we see there is a correlation heat map stating that the counties, different counties correlation between each counties, and we developed this heat map. Next slide. So when we come to our model, we used a min-max scalar system in the first time, then fitting polynomial regression, then validation prediction was done. Next slide. So we tried several different models with the time series data, and we used polynomial regression, Sarinian, XGBoost, Prophet, scalars, min-max scalars for transformers, log transform, no transform. We tried these different models. Next slide. So we used the root mean square error as the error metric, and the polynomial regression model gave the loss error, and we used that to predict the future cases. Next slide.
You have 30 seconds more.
So as you can see, the data ends at the 520th week, and we were able to predict until the 620 weeks, 28th week, which means about 100 weeks. And our model predicts at Budapest the highest and Zala as the lowest, and which was pretty much close to the real observations. Next slide. So in conclusion, the data behaves in a similar manner to the findings from China. There was an article in China that stated that there is a surge in spring and winter. So spring in Hungary falls during the months of March, April, and May, and winter falls during the December, January, and February. So there is a correlation between the mean average temperature and rainfall of each city, and there is a spike or rise in the case counts during those seasons. So next slide. That was pretty much our conclusion from this project.
Thank you. Your time is up. Thank you. Thank you very much. Ohakim, you have a question for the team?
Good one. Nice one. Gloria and team. I do have one question. This conclusion, you said you can study in China, and you talked about stuff like spring and winter and the month. So can anybody hear me?
Yes, we can hear you. We can hear you. We can hear you again.
I asked the question like, so did you build a model? How did you represent the spring and winter in the model?
Okay, so in the model, our model predicted a rise in the spring and winters. I mentioned the months specifically, the March, April, May, and the December, January, February seasons. There was also another finding that exists the correlation between some countries that share borders. Those states also have a higher cases. And as we mentioned, there is a rise in those specific reasons, and we predicted data week-wise.
Okay. Thank you very much. Thank you very much. A nice one.
All right. Thank you very much, Ohakim. You can stop sharing your screen now. Moving on to the next team, we have team Matplotlib. That is Emmanuel and John. Are you on the call?
Good afternoon, everyone. Can you all hear me?
Yeah, I can hear you. Start sharing your screen now, please.
Okay, I'm trying to share. Can you see my screen now?
Yeah, your time
Can you see my
starts now.
screen? Welcome once again to this project, and I'll be presenting. My name is John Mickey. I'll be presenting with my colleague, Emmanuel. Our project is titled Predicting the Scores of Women International Football Matches. And this is a sneak peek of how our team looks like, with everybody with his own tags. We have recognized as our statement the attention and interest to women's international football, which has really been low, and we aim in this style project to uncover valuable insights into the progress and accomplishment of these female athletes in international football through data visualization. We also seek to develop a robust regression model to predict the home and away scores accurately. There are already existing solutions that offer similar results, like the Betigi, Soccerway, the 538, and the rest. In our own approach, we actually splitted our workflow into 4 different units: data cleaning, the exploratory data analysis, modeling and evaluation, and then the deployment. And doing that, our data was actually gotten from Cargo, which contained about 4,884 recorded results of these women international matches. We went through with data cleaning as a regular procedure, And then we dived into our exploratory data analysis, which we had some keys that included the active home teams, active away teams, tournament-wise distribution, the goal difference to show the competitiveness of the matches, the goal tournament that has a high scoring, the type of venue, whether it is neutral or not, and so many others that time might not permit to explain now.
Yeah, for the model deployment, we use suitable model to train our data set to predict the home and away scores, and did feature encoding for effective visualization of categorical values, explore different regression algorithms like linear, ridge, lasso, and elastic net, and so many others. From the picture you see here, it gives you an overview of the evaluation performance of the metrics we use, which is MSC and R-square score. We actually selected random forest classifier as our final model, employing reset CV for hyperparameter tuning. Now, onto deployment, we prepared a requirement file with the necessary packages and dependencies for seamless deployment. Launch the app on Streamlit Cloud, granting access to users via the internet. From what you can see here is the UI, the user experience of the women football match predictor. From what you can see here, for Thailand versus Australia, it gives us a predicted score of 2-3, with Australia likely to win the match. In summary, we developed a random forest classifier model for predicting the home and away scores of football matches, successfully deploying the model using Streamlit and creating a user-friendly interface for assessing prediction. Our recommendation for future work include exploring additional features, advanced techniques, and also a larger data set to bring out the best or improve the match predictions accuracy. Now, we're also looking into a more comprehensive data analysis with a guided feature selection and engineering, considering feature interaction and incorporating a time-based feature to enhance our model performance. Thank you all for listening. My name is Boniface Emmanuel, team lead, team Matplotlib lead. Thank you all.
Thank you very much for that quick and wonderful presentation. Ayene, you have any questions, contribution from the team?
Okay, which of the page exactly? This.
Where you have the charts.
Yeah, I have charts.
Okay, yeah. This one.
This one? This,
no,
right?
The one before that.
All right. Yeah. Yes, I'm with you here.
Okay, so what exactly is this chart telling us? Can you explain more?
Okay, like I said, the data set had about 4,884 results of scores of matches in different tournaments. So in training our model, we had to look at this data set in an analytical way. And part of the things we considered, we looked at the 20 most active home teams based on the results that are at least 30 fixtures. We looked at the 20 most active away teams. We looked at the tournament-wise distribution, which you can see that majority of the match distribution was UEFA Euro qualification from this pie chart. And we also looked at the goal difference for each of the matches to let us know if it was a competitive match or not, which will help the model in predicting score. And they will look at, okay, is it a neutral venue or not? Because these are factors that actually affect the intensity of a football game. And we looked at the tournament itself, whether it is a high scoring tournament or not. And then we also looked at the football culture of the host. You know, some countries have so many interests in football, which can influence the results of the model.
All right, that's fair. So about the tournaments wise match distribution, can you tell me the list?
Pardon?
Yeah, I'm not sure I got the explanation for the tournaments.
Okay, tournaments wise, it means that, you know, for instance, there are football competitions globally. Some could be a country competition, it could be club, It could be, let's say, like we have African Cup of Nations, we have European qualifications. So these are different tournaments. We have the FIFA World Cup as a tournament. We have the AFC Championship as a tournament. So in each tournament, there are expectations for every tournament. Some tournaments are more competitive than others. Some tournaments have high scoring goals than others. Some tournaments have even low scoring details. Some tournaments have different features that are consistent with the tournament, because we believe that everything that is happening now has happened before, and they might be happening at different
So
times.
the highest proportion here represents
from our data set, it represents the amount of data we have for that competition, meaning that it's higher than the ones we have for the other competitions.
Okay, so what's the list from here?
The list from here is
CONCACAF Championship.
I'm trying to get at a point, right? I cannot tell immediately what the list from here is, right?
Really?
Because this is quite cluttered. Because this donut is quite cluttered. So I would recommend that in future iterations, right, you use a chart that would allow you to see this at first glance. I wouldn't recommend using the donut or a pie chart when you have as many distributions as this, when you want to show so many proportions like this. Okay, so it's taking a lot of explanation on your part for me to get what this was intended to show.
Thank you for that. Thank you for that. While I accept that, I didn't tend to disagree, but maybe it could also be because of the screen size that we are using. Because if this was in that, I'm sure you'll be able to see these details more clearly. But then we've taken note of that for future recommendations.
Okay, so what features? My last question is, what features did you use for this? Can you explain some more on the features you used?
Go back. Like go back. Yeah. We actually no. Go back. Front again.
Front. Okay.
Yeah. These are the features we use in training the away and home score. So we use the dates, the name of the home team, the name of the away team. Then we also use the name of the tournament, the CE, the country, and the neutrality of the game. Yeah.
Okay, so did you have any challenges with the features that were available to you? Was there any thought about possibly other features that you could have used for this?
Yeah. Football matches, there are other factors that actually influences freedom. That's why from our recommendation, we talked about adding for feature updates. We talked about adding more features to the DC, and also adding more features like like the player statistics, the weather conditions and other stuff. Also, we also did encoding, because for categorical data set, what we actually did, we did label encoding, because this is a categorical data set containing strings and the like. So we did label encoding to give each team or each value or each feature a specific number which was marked, through which we are able to train our model. Yeah.
Okay, fair enough. That's all from my end. Well done.
Yeah.
Thank you. All right, thank you very much, Anna. You can stop sharing your screen now. Moving on to the next team, we have metadata. Max, are you here? Team metadata.
Yes, we are here.
All right, let's start sharing the screen now.
Yeah, good afternoon.
Your time starts now, so start sharing the screen.
Yeah. Hold up. Can you see my screen?
Yes, we can.
Hello, okay, can you see
Go
my
on.
slides now?
Yeah,
Right.
we can.
Thank you. Okay, so our project was the gold market analysis and price prediction by the metadata team. It was the project lead was Logosu Teku, and co-lead was SK. Not sure. So our problem statement was the price of gold is volatile, so we're trying to create a model that will help predict the price of gold and compare it and adjust the closing prices with a high degree of accuracy, so as to help investors like make well-informed decisions about where to buy, when to buy or sell the gold, how to compare the prices with other currencies. So some existing solutions included gold price forecast.com, is a site that provides gold price forecasts, Investopedia, Quandle, and Google Cloud platform that helps build models and predict gold prices. So based on existing solutions, we're able to look at that and work on our own model. First approach we did was to collect our data, which is the data set that Hamoye gave us. Collected it, rankled it by cleaning it, making sure it's well organized, and we're able to pick the parts of the data set we would use for our model, for our project in EDA, during the EDA. The model development, after doing the EDA, exploratory data analysis, and see exactly what we need for the project, we started developing a model for it. And deployments, we deployed it and tested it with, we ran it with some test data. Work was assigned based on volunteering basis and was coordinated through team meetings and one-on-one meetings on Zoom and Slack call. The data sets came from Cargo, had 1,700 plus samples with 84 features. Was cleaned and tidied after data wrangling. And during the process of development, we dropped some outliers and with high collinearity during model development. So during EDA, we found out that the gold prices are relatively stable. I've shown you the photos that you can see. It's relatively stable with very little fluctuation, which makes it like a good factor for comparing with other prices. It's also explained why gold can be used as a guarantee state solvency. It was able to give us good results based on the small amount of samples, which was 1,700 plus. We were able to develop the model using the lasso algorithm to train the data set, because it seemed like the best to handle this particular model. So in summary, the main observation was that gold prices were stable with very small fluctuation range, which makes it a standard for comparing to other prices. Challenges we faced was time management, whereby we didn't seem to have enough time to work on the model further and develop it more and test it with more and more data. And also another issue we had was team management, where collaborators were, out of the 26 collaborators, only 3 were actually participating, which includes Lugosu, I, and Gospel Myro. Active collaborators could have been better coordinated in their work, because it was hard to get them to work together at the same time. And many people, we noticed some people were having issues with adapting to Slack, especially those that were not active. They had issues with adapting to Slack, they were not used to it or something. So based on these challenges, what we recommended solutions to Hamoye was we needed to filter, and what it could do better to find out ways to filter out participants, so as to make the project more easier to accomplish. Filter out active participants and get those who are interested and active. And also having a senior from Hamoye initiative will help, so as to give us general advice on how to go about our project, especially for those who are just very new to such program. And that is all. Thank you. You can questions can come in now.
All right. Thank you for your presentation. Before I call on the judge, from your slides, you're talking about the recommendations. The recommendations will be related to your project.
Yes.
That's how you carried out your work, not how your teammates perform. We're talking about the recommendations on the further work of your project. That was what that recommendation is supposed to be. But let me give the floor to the judge. Yeah, let me give the floor to the judge. Joaquin, do you have any questions for the team?
Can you hear me?
Yeah, I can hear you.
All right. Thank you very much for your recommendations. Okay, so I want to ask, are you saying like your team wasn't okay? You don't worry. So this is gold market price prediction. Like I don't see anywhere where you talk about like the features you use. I just saw one plot that's for EDA. It's not enough plots about like these plots like this don't tell anything. They don't tell anything about
Yes.
what features. Yeah.
Oh yeah, we are so sorry about that. Actually, we were going to put in more plots, but due to the limited amount of pages we were told to have for our presentation slides, we didn't want to fit it in so many information. But most of it is still available on our GitHub link for the project. Do I still need to open it on the screen to show you the work?
No, you don't need to. You don't need to. You don't need to. You can send the link on the chat. But okay, you didn't talk about the features you use for the gold market price prediction. This is actually time series related. You want to predict the price of tomorrow, next week, gold, and if it's something like the forex market, you have things like the highs, the lows, the current price, the closing price, stuff like that. Other things like maybe about the political variables, stuff like that in your model.
Yes.
And so I don't see any of that here. I can only see
I'll refer back.
RMSC score.
Okay, I'll refer back to Logosu now to explain further on that part. Logosu, are you?
Oh, who? There's no need for that. The time will not permit for that.
All right.
Please.
So the
thank you. Just share
outliers.
the link and
All right. I'll share the link now.
all right. Thank you. Thank you very much.
Okay, thank you very much, Joaquin. And before you stop sharing your screen, to further buttress your point about your slide, the limit was just for your project documentation. The slides didn't have any limit. If you paid attention, you see that you could explain more on the points given. So it was only the limit on your project documentation, not the slide. So probably you didn't get that part. But anyways, thank you very much for the presentation. We're moving on to the next team now. You can stop sharing the screen.
Okay, thank you.
So the next team would be Team Neural Network. We have Ibemosi and Adefabi.
Yes.
All right, you can start sharing your screen now.
Good afternoon.
Yeah, we can hear you. You can go.
Okay, thank you. Good afternoon. My name is Ebemosi. I'm representing Neural Network with Abdulaziz. Okay, so our problem statement, the aim of this project is to use data to gain insights on technology company layoffs and then make informed decisions from the data that we've collected. So a few objectives of this project. As stated here, we used to answer a few questions like the total layoffs per month and year, how the IPO of company status affected the layoffs, then which industries were most and least affected by the layoff, which companies were also most and least affected by the layoffs, then which locations had the most and fewest layoffs. Okay, we highlighted a few solutions here, but we used the second solution. We used Python, and we used Power BI actually for our visualization. The source of our data was from Kaggle, which was the given source for the project. Then we downloaded it as an CSV file. We've checked the data. It was just a few fields that were in it, so we had to download more data from another online file that's like web scraping. So we used layoffs.fyi to get another data set, which we combined with the given Kaggle data set to get more data. Because after cleaning the data set from Kaggle, we had to drop some columns. So it made the amount of fields we have very few. So we had to use the one from the layoffs.fyi to complement it. So we'll have more fields to work with. So that will improve data integrity. So while we're cleaning the data, we checked for missing values. We converted the data types to match each other, then converted timeframes. We checked the data quality generally. Due to some inconsistencies, that was why we added the second data. So we also cleaned the second data set. Then after the transformation, we had like 1,068 fields, which was double the initial record from the data set, the first data set. So we used that. Then we created a heat map to, I'm sorry, I beg your pardon. A heat map was used to plot to find correlation among the different attributes, but no correlation was found basically. So we went on to use data visualization where we plotted different bar charts to find relationship between the different attributes. Then for the dashboard aspect, we use Power BI to create a dashboard for better understanding from the insights we've gained after cleaning the data and the visualization. So a few of the questions that were addressed during the EDA process include I listed them previously, like the total layoffs per month and how the IPO company status affected the layoffs, which industries were most affected, least affected, which companies were most and least affected, then the locations that were most and least affected, and the average trend analysis for the layoffs. So a few of the results that we've gotten from the whole analysis includes the total layoff per month. January has the highest number of layoffs, while September has the least. Then the total layoffs per year, 2003 has the highest layoffs per year with 192,000. Then 2021 had the lowest with 7,000. If
You have 30 seconds more.
All right. So we have also highlighted here the top industries that were least affected. Artificial intelligence has the least among these. Then the ones that were most affected, retail has the highest. Then the companies most affected, Amazon has the least data for that. Okay, so this is what the Power BI is just emphasizing what the analysis has done, just to show it in a more, to improve the visualization actually. Okay, so I'll just read the conclusion. January is the month with the highest. I've previously stated this. The year with the highest layoff is 2023. I mean, the average layoff per month is 100, and 20,700. Then that depends on the mall. The Amazon has is the company with the most layoffs. Branch is the company with the fewest layoffs. SF is the location with the highest number of layoffs. Then Boys is the location with the lowest number of layoffs. So our recommendation is that further data should be collected later on. So have a target variable for prediction purpose. Thank you.
All right, thank you very much for your presentation. ANA, you have a question or contribution?
Yeah, first of all, I want to appreciate the work that was put into creating the slides. Then my question for you is, what do you mean by companies that were most affected by the layoffs? I'm not clear on that phrase. What does that mean? Can you hear me? Am I audible?
So I'll answer that question. So what we meant by companies most affected with the layoff, we're referring to companies that had the highest layoff across our data sets. So we looked at the companies vis-a-vis their layoffs, like this is the number of layoffs they had. And then we analyzed them top 5 companies that had the highest layoffs across that time period.
Well, I thought perhaps you meant maybe subsidiary companies or that were dependent on a particular company that might have been affected. Okay.
Sorry, I didn't get that. Can you repeat that?
I said I thought perhaps you meant like other companies that had some services that was provided by a particular company that may have been affected in some way by the layoffs.
Okay, no.
Fair enough. Okay. All right. So you mentioned the fact that you didn't find any correlation. So what features did you use exactly? What were the features?
Okay, so one of the issues we had initially was that most of our data sets, most of the columns we had them were high dimensional columns. So they had them columns around it, features like company name, features like HQ location, features like the report date of the layoff, and then the industry type. So the high dimensionality was why for us to be able to even do to do any encoding that can maybe change this and make us be able to do a prediction model. And another thing that some of the columns that we had to generate ourselves, like the total workforce. So we had to use the percentages of the impacted percentages of the impacted layoff staff to impute the workforce. That is, we had the layoff numbers, and then we have the percentage that were impacted of the workforce. So we use those 2 columns to generate a workforce. So even after doing those particular to get like a numeric data sets that we can even try to use. So we also noticed that the correlation were non-existent. We're having correlations of 0.001, showing that there were little associations between the target and the predicted, the explanatory variable rather. So we just decided to that's why our conclusion is saying that we need to get more data sets to be able to data set that would correlate with our target variables that at least can give our prediction models and more accuracy, because when we saw the prediction models, it was not even performing better than the baseline. So we just felt there was no point in building a model. So that's why we focused on the dashboard and the analytics.
Okay. All right. I do have one more question though. Can you go to the existing solutions part? The slide on existing solutions. Okay, you said that one of the cases, right, does not provide proper answer to our challenges. Okay, you have explained that. I think it was the solution 2. The data was inconsistent and not supplied with relevant options. So where exactly did you scrape the additional data that you used to complement?
So we got the additional data from layoff.fy, that's the website. So I think it's the website that keeps information about company layoff, technological company layoff. Okay, so our original data set was from Kaggle. So we had to do a little web scraping to concat it with the first data set.
Okay, so how did you handle cases of, did you have cases of duplicates? I believe you did.
Well, so I don't recall any case of duplicates. So we didn't have any cases of duplicates from the data set. No, we did not.
Well, that's interesting. Okay, that's all from my end. I will check up on this some more later. That's all the questions on my end. Thank you.
Thank you very much, Ene. Thank you, Niran. So you can stop sharing your screen now. Moving on to the next team, we have team Plotly. We have Miracle and Christiana from Team Plusly. All right, the time starts now.
Hi. Good evening, everyone. My name is Christiana Anarado. I'll be presenting with Miracle, and we're representing Potley Group. Our group project is on the prediction of chronic kidney diseases. Sorry. Oh, wow. Wow. Move to the next slide. Please, sorry.
You can use the yes, that part. Yeah.
Okay. It's fine. Here are the list of my team members in the group. Our problem statements. Chronic kidney disease is a prevalent and serious health condition affecting millions of individuals worldwide. Understanding its complexity and developing effective strategies for its management and prevention are crucial for improving patients' outcomes and public health care. Our existing solution. There are solutions already existing, and they are regular screening, education and awareness program, the renal replacement treatment like dialysis. Our approach. We developed a machine learning model to predict the likelihood of an individual being diagnosed with chronic kidney disease. We also leveraged the machine learning algorithm for early detection and diagnosis. At this point, please allow me to use CKD as a short form for chronic kidney diseases. Here's our flowchart. We actually had to define our problem statements, which moved down to model deployments. Our data sets, it was gotten from UCI machine learning repository, which contains about 400 rows and 25 columns. We performed data cleaning and pre-processing, where we identified and handled missing variables. For our numerical variables, we imputed the mean. For our categorical variables, we imputed the mode. We also identify outliers in the white blood cell of our data set counts, as shown in this slide. Sorry, what's wrong today? Okay, we also had balancing of our own data sets. Realizing that our target variable, which is the CKD class, was imbalanced, we used random undersampling techniques to tackle the issue as seen on the slide. The unbalanced is seen on the left, while the balanced is seen on the right. We further visualize our data set using heat map, and this shows that there is a strong correlation between certain features such as age, the blood group, the blood pressure, and the urine gravity, etc. Oh, good. Okay. The visualization on my left shows the histogram of the age significance. The majority of the individuals in our data sets falls within 40 to 60 years of age, while that of my right, the scattered plot between blood pressure and blood glucose, reveals no significant linear relationship between the two variables. Individuals with hypertension tend to have higher serum creatinine level, as seen in this box plot, and the Violin plots reveal the age distribution across different classes, that is the CKD and the not CKD. Still on the dataset description, the pair plot was used to highlight the potential correlation and pattern between multiple variables, and the bar plot for the average hemoglobin level between CKD and not CKD. Our model overview. We modeled our data sets and the performance of our data, and the different classes model that was used was random sampling classification, random forest classifier, supports vector classifier, logistic regression, and gradient boosting classifier. Among the classification model, the random forest classifier and the gradient boosting classifier achieved the best accuracy with a 1.0 score, as seen on the screen here. This is the graphic representation. This confusion matrix is showing that the graphic representation of our model, which indicates that the model achieved a perfect classification performance with all classes classified correctly in their respective classes using the random forest classifier. While the curve you can see on my right, is the L shape, which indicates that the model is perfectly distinguishing between the two classes, which is the CKD and the not CKD. We did feature importance, and this bar plot reveals the most important
sorry, you have
range
30
from
seconds
highest
more.
to lowest for predicting CKD outcome as seen. Age is the highest here. We did deployment. We used Streamlit for our deployment. And our dashboard is showing the relationship between certain features. In summary, we observed the majority individuals in the dataset falls within 40 to 60 edge of range. This is also a strong correlation between certain pairs of feature in our datasets. Individuals with hypertension tend to have higher serum creatinine level, indicating a potential role of hypertension in kidney function. Challenges faced were handling of missing data and balancing of imbalanced datasets. In conclusion, we analyzed this dataset based on the available data that we got, and this can be used to support healthcare professionals. Thank you very much.
All right, thank you very much for that wonderful presentation. Ohakim, you have any question for Tim? Contribution?
Good day. Nice presentation, Christiana. Are you the only one in your group?
No, actually, I'm here. I'm also partnering with Christiana, yes.
That was a nice one. That was a nice job. I have something to say, Sha. At the end, you used metric accuracy. I would just like to suggest that when you work with classification task, you have imbalanced data set, you don't use something like accuracy. I don't know how I can't explain it here because it's a very long topic. But then better if you use something like precision, recall, most especially precision and recall, like one of them, depending on what you want to optimize. Precision has to do about the true with the true positive. Like you want to make sure the people that I think the people that are taken as positive are actually positive. Like, and the recall is about you I think reducing and look into that. It's just my take, like my advice for the next time you want to work on something like this. So but the rest are the nice work, nice work. I know that handling the missing values here in something like medical cases, something in this field is kind of tricky. We don't know what to do, whether to use the median or the mode. But you can always look at the distribution and know how it is, whether it's skewed, then know what um, value you should use for imputation, and also the outlier removal. Um, there are different techniques for outlier removal, and I would just like you guys to just search more, do your research, and it's very very nice one, and there's room for improvement. Thank you.
Thank you so much, sir. Thank you.
All right.
All right. Thank you very much, Ohakim, for that nice recommendations. You can stop sharing your screen now. Moving on to the next team, we have Team Python, Oladimeji Williams for Team Python.
Yes, I'm here.
All right.
Your
time starts now.
I hope you can see my screen.
Yes, we can.
Okay. Hi, everyone. Oladimeji Williams is my name. Myself and my colleague, Confidence Ujako, will be standing in for Team Python in presenting this project titled Predicting Survival of Tongue Cancer Patients. These are the representatives of Team Python, and here is the list of the other active members. Although tongue cancer is not so common in Nigeria, it is widely regarded as a prevalent disease affecting mostly South Asia, claiming well over 145,000 lives every single year. Therefore, this project seeks to build a comprehensive Power BI report. It also aims to develop machine learning model in order to make future predictions. A lot of solutions to this problem have been developed by several researchers. However, most of them do not optimize the metric for evaluation. So since the data is clean, we just wrangled the data, explored, performed feature engineering, built machine learning models, evaluated the models, tried a series of combinations of examples, and then finally deploy the best model. The dataset we used sits on Zenodo portal, and with over 1,700 cases and columns. The target variable is named survival. However, only these 6 features out of the 12 columns were used. There is high class imbalance in the demographic of the cases and the target variable. In this dataset, we can see that females are less than 300, while males are over 1,400. Also, majority of the cases resulted to death, as 0 stands for survival, while 1 stands for death. So now Confidence will take us through a slightly deeper analysis of the data on Power BI.
Okay, thank you, everybody. So from the data sets we have here, the analysis done on the data set, we have 1,712 number of patients, and 25% of the patients survived, while 75% of the patients died. And looking at the tumor stage, we can see that stage 1 has the highest number of cases, about 611 patients with 36% of the data set, followed closely by stage 2, by stage 4, then stage 2 and stage 1. Now, looking at the survival by the tumor stage, we can see that stage 1 has the highest number of deaths, followed closely by stage 2 with the highest number of deaths, and stage 4 had the highest number of survival, which is about 13%. Now, taking a look at the table we have here, the table focuses on different factors, about 4 factors that had the total amount of death. So we have when the patient, stage 1 patient, and the tumor size stage 1, where chemotherapy was not received and radiation was not received, we see that that had the highest number of deaths, which is about 30%. When you scroll down to the end of the table, you can also see other factors mixing with the tumor stage, the tumor size, chemotherapy, and radiation. In this very highlighted point, where tumor size was 1 and tumor stage was 4, we can see that where chemotherapy was not received and radiation was received, it's about 0. So why is 0 is because the amount is quite small, 0.1, which is very insignificant. So yes, that's it. Go on, Oladimeji.
Here is the model pipeline. After sourcing for the data set, we prepared it, engineered the features, developed several models, evaluated the models, iterated over and over again, and then we deployed the best model. For the feature engineering, firstly, we checked for the important features using the p-value test. The higher the bar, the less likely it is to significantly contribute to the prediction of the target variable. So we can see that OP and gender, that they do not really contribute to the target variable. And really, it does make sense, because what this means is that the chance of survival of a tongue cancer patient is not dependent on the patient's gender at all. So in essence, we removed these 2 columns. Next, we checked for multi-collinearity between the features using the VI factor. So the goal here is to use features whose VI factors are between 1 and 5. So you can see that the VI factor for stage is too much. So we remove stage variable, and then we ran the test again, and you can see that age variable is just too much. So we dropped it and we ran the test again, and the features we can see here appears to be within the limits. Then we tuned the parameters of about 30 different models, trained and validated models, and here's the results. So because of the high class imbalance, our metric of choice is F1 score. So we can see that random forest classifier performed based on the data at this time with 0.92 F1 score. We also tried to assemble a series of these models together in order to improve the performance of our engine. So we can see that the ensemble of random forest classifier, ADA boost, and SGD classifier appears to be the best of the examples with 0.919 F1 score. But remember that random forest classifier only gave us 0.92, while the combination of these 3 models, including the random forest classifier, now give us 0.919. So the question is, which should we use? So for us to answer this crucial question, we delve deeper into the evaluation of these models with confusion matrices. Our positive value of choice in this case is death. So we're interested in capturing most of the deaths. So the example model correctly captured more of the deaths, giving us about 383 deaths while the random forest gave us like 380. Also, the example did better in the type 2 error, incorrectly predicting only 5 deaths as survival, while random forest incorrectly predicted 8 deaths as survival. So clearly, the example model is a choice model. So we deployed it, and here is the demo of how the prediction works on the web page after deployment on Streamlit. And some of the challenges associated with this project includes, but not limited to, insufficient relevant features, because 6 features is too small to predict the chance of survival of a precious and irredeemable life. So some of the models were also computationally expensive to tune, like the SVC, and it was eventually dropped because it was taking hours to tune. And here are the links related to the project for your perusal. Thanks.
All right, thank you very much for that well laid down presentation. That was interesting. All right, Ayene, have any question for the team?
Yes, quite an interesting presentation. So my question for you is, what did you do about the imbalance?
Yeah, so we could not treat the class imbalance because this is a data set relating to health. So if we say we should go by the general way of imputation, trying to simulate the data set to increase the number, it will not give us the accurate prediction because we're talking about life here, and life is irredeemable. So we rather worked with what we have, and then we treated the multi-correlation with the VIF factor just to reduce the effect of the class imbalance. And then we also used a good metric of choice in order to evaluate our model.
Okay, that's good. So that's all from me. I have no other questions.
All right, thank you very much, Ayene. Thank you for the title. That was a nice presentation. You can stop sharing your screen. So moving on to the next group, we have Team Sci-Fi, Chakrabroti and Niveda. Are you here, Team Sci-Fi?
Yes, sir. I'm Niveda. I'm here,
Yes,
sir.
we are here.
All right, start sharing your screen. All right, your time has started. Good luck.
Yes, sir. Hello, everyone. Good afternoon. Myself, I'm Niveda, and me and Mayuk are here on behalf of our team Sci-Fi for the presentation. Our topic is the therapeutic effects of music on mental health. Mental health is a critical aspect of overall well-being. Various factors contribute to mental health disorders. Music has long been recognized for its potential therapeutic effects on mental health. The purpose of our presentation aims to explore the therapeutic effects of music on mental health. Here we examine the scientific research and evidence supporting the positive impact of music on mental well-being. So this is our flow of process. Data collection, data preparation, modeling, training, feature engineering, and model evaluation. So we have our data set from Kaggle, and the data sets contain many informations. So at the conclusion, or in a data sets, we have a popular streaming devices is Spotify, and the most popular genre is rock. And then we have used some common supervised learning algorithms like logistic regression, decision trees, random forest, SVM, and neural networks, out of which we have logistic regression. It's the most accuracy in our project. Over to Mayuk. He will present the presentation of model part. Thank you.
Hello, everyone. Good morning, good evening, afternoon. So while looking at the data preparation part, we'll have a look at the 6 features out of 33, which we have used. The rest have been dropped, keeping in mind the target variable, which is music effects. We have used age, hours per day, the BPM, anxiety, depression, insomnia, and the OCT. So as we move forward, we had to keep in mind the outliers when we were preparing the data and everything. So BPM, when we had to talk about BPM had some very disturbing outliers which needed to be replaced. So we started exploring values around the mode and median. And thereby we reached a particular threshold to set maximum values and fill in missing values with the mean. As you can see with the first image, when we started understanding the count versus the BPM, the beats per minute, the mean stood at an abnormally high amount of 1.5 into 10 to the power 6. Now, which implied that outliers were playing a very pivotal role in driving the mean forward, where the median stood at 120. In the next step, we see after the outliers were removed, we are having a almost proper bell curve there. So we are kind of looking at a normal distribution here. So the standard deviation went down to 30.7, and we are looking at a mean and median value of 120. So when we started cleaning the data, we changed some of the variables to make them shorter and easier to analyze. The primary streaming service column responses like other streaming services, and I do not use a streaming service, were changed to other and none. Some categorical variables were changed to numeric, to how frequently you listen to music. And then missing values were handled like in age and BPM, and categorical values, they were replaced with the model value. So after data cleaning, some visualizations were carried out on the data set to get some insights about it. As you can see that Spotify has clearly been the ruler here. It has, and that's followed by YouTube Music. And then there's a significant number of people who do not use a streaming service. And when it came to the genre of the particular music set, we see that rock still dominates the set, followed by pop music and metal. Now we move on to the training, the evaluation, and the validation of the modeling. When it came to model training, the dataset was split into a training and testing dataset with a particular percentage of 80-20. Now, different regression models were used, like my colleague Niveda has pointed out. We had used logistic regression, decision trees, random forests, KNN, SVMs, and a particular defined neural network model. As the model was evaluated, we are looking at certain amount of accuracies here. And out of those, logistic regression was clearly dominating the charts. And here we look at a particular bar chart of the accuracy, and logistic regression has an accuracy of 78.37%.
30 seconds more.
I'm sorry.
Go on. I said you have 30 seconds more.
Okay. So logistic regression has the highest accuracy with the 78.37%. And these are the classifiers that we have used. And most of the classifiers has a proper range, except the decision tree. We lost out on our accuracy over there. Moving on with the results, conclusion, and the recommendation part. We have found that when we are tuning the hyperparameters, the results, there is a proper improve in the result. For example, adjusting the max BPM feature down from 200 to 190, it resulted in an increase in model accuracy from 77 to 78% for logistic regression, as well as slight improvements in other models. And more training data would have been helpful. We had, as you can see from before, we have been operating with a very less number of records, which is only 736 records. And so if we could have more data to train the model, maybe we could have had better accuracies. And moving on, this is the point when we increase the training data to 90-10 split, the accuracy went to 80%, for example. And I think with that, we come to the end of it.
Okay, thank you very much for that nice presentation. Ohakim, you have any questions, contribution? Tim?
Okay, nice one. Seems sci-fi. I just want to add something that, when you said if you had more data, you might have had more accuracy. I just want to try to see. You understand? And tuning. I know it's a very, very interesting thing. I don't know, hyperparameter tuning can only squeeze out like highest 3% of accuracy. In some cases, I only see 0.3, 0.4% to do something like something they call error analysis or post-model exploration. It's kind of like what are those data you get? So you have to do more EDA on that part of it yet. So that might be something that might increase your accuracy to maybe 0.9, stuff like that. And yeah, this is a very, very good like presentation. I love the work you put to it, but just saying further in the future, next time, something you can look into. All right, now, thank you.
Thank you so much.
All right, thank you very much for that nice comment. You can stop sharing your screen now. Moving on to the next team, we have team Seaborn, Thompson, Oreolua, and Shamsi. Are you here? Team Seaborn.
Good evening. Good evening.
Okay.
Yeah, I'll be representing Team Seaborn.
Good evening, everyone.
All right, you can start sharing your screen now. The time has started. Please share your screen.
All right. Okay, can you see my screen?
Yeah, please proceed.
Okay, good evening, everyone. My name is Busayami Thompson Ajayi, and I will be representing Team Seaborn for this presentation titled E-commerce Sales Analysis. This slide shows the team members that helped make this project a reality. Now, for our problem statement, for this project, we want to gain more insights into customer preferences and the performance of each product category in the market. The following key challenges that were identified include inefficient resource allocation and the lack of understanding of the customer segment. Our approach to this project involves data collection and processing in the cleaning and exploration of the data collected. Feature engineering was done. For this, we created an extra column called revenue to capture the income from each order. We also performed analysis and implemented a k-means clustering algorithm. Finally, we visualized our resulting data set using Power BI, which we're going to see later in this presentation. So for the description of the data set, this data set was imported from Cargo. It contained information on Amazon India sales from March to June 2022. The columns also contain data such as SKU, which is product ID, ship states, and the rest, as we can see in this slide. Okay, for the cleaning and preparation, and cleaning, we imported data into our notebook using Python, and we observed that the collected data had 24 columns and 128,975 rows. There were also 10 columns with null values, and they were cleaned appropriately. The steps taken to do this are highlighted in this slide. The date column was converted to date time for better exploration, and some columns were dropped. Further cleaning steps were taken as shown in this slide. As you can see in the lower snippet, we performed forward fills where necessary. We filled with zeros, cancelled, and unknown. This was done with the aim of preserving data quality. So we clean the ship state column using fuzzy matching, which helps identify similar elements in our data set, as we can see here. So for the data exploration, we can see that, visually we can confirm that the data set truly contains orders between March and June 2022. You can also see that the highest inflow was in April 2022. And also the highest quantity of goods sold was in April. This heat map shows that there's a strong positive correlation between amount, revenue, and quantity. So it's safe to say that the revenue feature is strongly correlated because the amount is strongly correlated with the amount and quantity because they were used to derive revenue. From here, we can see that most orders were filled through Amazon, about 70% of them. And then here we see that the highest number of orders were made in the month of April. Here we see that the most, this is not so clear, sorry about that, but we see that the most sold product category is set. Now for this horizontal bar chart, we see that the most ordered cloth size is the medium size with a count of 22,709 orders. So for the data analysis, these were the questions that we aim to answer. How does the amount vary across different sizes of products and categories? Which product categories or specific products are top performers in terms of sales volume and revenue, and whether there are any seasonal or temporal trends that significantly affect sales patterns. We also aim to categorize customers based on their orders. So from here, we see that the most expensive size is XL and the most expensive product category is set. And also we can see that set cotton and Western dress are the most popular categories. We see that Sunday has the highest revenue while Thursdays have the lowest, meaning most people do their shopping on Sundays in India. And this is our dashboard, which I will still show properly. And these are the insights we're able to draw from the dashboard. Then the clustering, we're able to cluster our customers into 3 categories. Those that buy fewer items, those that and spend lower, those that buy fewer and spend slightly higher, and those that buy more and spend the highest. And these are the recommendations that we have based on our analysis. We believe that to maximize revenue, they should make more manpower available on Sundays, and then they should have more inventory of set cotton and Western dress. And the reason for high cancellation of set and cotton should be looked into. And this is the summary. So maximizing revenue in an e-commerce requires a strategic approach backed by data analytics. And this presentation has demonstrated that more companies should embrace data-driven insights.
Sorry, your time is up.
Drive.
Time is up.
Thank you.
Thank you.
Analysis. Yeah.
ANA, you have any contribution for the team?
Okay, walk me through the goal of this project again, please.
Okay, so the goal of this project majorly to understand the trends based on the given data that we have, also to be able to advise on what to do for this company that we are analyzing this data for, the steps they could take to maximize their revenue, which we can see here in the recommend. So we eventually made recommendations based off of that. So yeah, that's it.
Okay, so why was the reason for the high cancellation? Like, why couldn't you look into that?
Okay, so the reason for the high cancellation, the reason why we couldn't look into it was the data was not sufficient. The description of the shipping status, which showed the cancellation, was not robust enough to capture the exact reason. So if we're going to look into the reason for high cancellation, it means that data regarding a reason, say a remark or a kind of poll that or review that shows why people cancelled will be needed.
I mean, did you try to search for this? Did you try to check if this data was available?
Yeah, so it was just available on Kaggle, and when we tried getting more data relating or additional data, we were unable to.
Okay, all right. It's a good work, regardless. Well done.
Thank you very much.
All right, thank you very much again for these contributions. You can stop sharing your screen now. And we're moving on to the next team. We have team SVM. It's Caleb, Isha, and Fine here for team SVM.
Yes, we're.
All right, start sharing your screen, please. All right, your time starts now.
Okay, I hope my screen is visible and I'm audible.
Yes, we can see your screen. Please proceed.
Okay. Hello, we are from the group SPM and our project was on employee attrition prediction. I am Isha Desai and my group member Caleb is here to present with me.
All right. So good afternoon, everybody. Sorry, afternoon in Nigeria. So I'll be giving the context for our task. So employee attrition. From the word attrition, it means something that reduces with time, something that reduces gradually. So employee attrition is talking about the problems that I encountered, whereby the rate at which employees leave a particular firm, company, organization is higher than the rate at which they are taken in, and this is usually due to a number of factors that are usually beyond the control of the employer. Some of them include lack of professional growth, a hostile work environment, sometimes issues about their monthly income, work-life balance, and environment satisfaction. All right, next.
So the problem statement states that our goal in this project was to analyze employee-related data and identify factors influencing attrition, build a predictive model that accurately predicts employee attrition based on various features as in the columns that were available in the data, enable organizations to take proactive measures to improve employee satisfaction and retention. So our approach. First of all, it was about data collection, the first step in any data analysis problem. And for data collection, we were given a site in Kaggle for employee attrition and its causes. We got the data from there. For exploratory data analysis, the reason was that we had 34 columns in our data set, and using all those columns would have led to an overfitting and a complex model. So we had to identify the only valid columns or the features that were required. Next up, we had feature engineering to check the meaningful features and pre-process the data. And then model selection, training and evaluation, and interpretation and insights. I would like to delve a little bit in each one of them. I'm sorry.
All right. Yeah. So to the description of the data set. Yeah. So the data set is one that was sourced from Coyote, a fictitious data sets built by Kaggle data scientists for research purposes and for companies that are facing issues like this to be able to understand and predict trends that could happen in their companies. I mean, companies that are faced with high attrition issues. So the data set has 35 features and it has 1,470 rows. Some of them include age, gender, job role, departments, training history, and what we are actually our target variable, which is attrition. So it's either a yes or it's a categorical future. So the data set actually provides a comprehensive view of employee attributes and allows us to understand the factors that contribute to attrition within the organization. All right, so the next. All right, so the data sets, talking about how we went about it. So the data set was loaded into the Python library using our pandas library, loaded as a pandas data frame. Then the data set was clean. It had no null, nor missing values, no outliers. Then the text data was transformed to categorical data using original encoding. This is to transform the text data into a form that is readable by the machine into numerical values. And then data set was also standardized using a standard scaler. This scaling allows for scaling. It helps to scale numerical feature it helps to regularize numerical feature to a fixed range, typically between 0 and 1, and this is for the purpose of avoiding feature dominance, to handle different units and ranges. It also helps to minimize the impact of outliers, and then it helps to prevent overfitting. So some features were dropped that were not relevant to the analysis. We had to drop the employee count, which value is always 1, and we also had to drop the standard hours, which is the same for every employee. So in the next slide, we have a bar representation of the most important features that help predict the employee attrition. So we see that the top three, top most important
30 seconds more.
The top most important 3 are the overtime, the department, and the job level. All right.
As we can see here, this is the EDA for our model, the various attributes and their dependence on the dependent attribute. After that, we have trained in 3 models. One is random forest, the second one being logistic regression, as it was a classification problem. We have used XGBoost and LightGBM2. As you can see in here, we have analyzed and compared the F1 scores and the precisions of all these models. And then finally, we have come up with recommendations, as our project was about giving a finite solution to the company regarding how they can solve their employee attrition issue. So in the end, as you can see here, XGBoost gave the best training and precision and F1 scores. So we have ended up using XGBoost. Moving on. As I said, our model was, we are comparing different models here, and we have used smooth. The reason being, the data set was highly skewed. As you can see in here, the number of people who have left, the data of the people who left, and the data of people who did not leave, it has a very skewed comparison. So we have used smooth to oversample a little bit so that we have a highly balanced data in order to avoid a biased model. After that, we have deployed our application using Streamlit. This is the interface. The application looks like this. What we basically do is we just drop a CSV file, and for example, something like this. It shows you the view of the CSV file. This is the data of all the employees that a company has. And when we click on predict, we come to know if that particular employee ID is bound to stay or bound to leave. As we can see, there's high chances of employee ID 3 of leaving. So this was our project. To summarize it entirely, we have seen that overtime among all the other attributes was the biggest player when it comes to employee attrition. While employees with definite age or employees who work overtime are very likely to quit their role, this suggests that the organization should employ more employees to fill in this role or to operate in different shifts. We have built a model to predict employee attrition. This model would help to know which employees
I'm sorry, your time is up. Your time is up.
I'm done. Thank you.
I had to add more time. Okay, thank you very much for that wonderful presentation. It was well presented. That was good. Oha, can you have any question from the team? Contribution?
Wow, that was a nice presentation. That was very, very detailed. Even the exploratory data analysis and all. Just I don't know. I was confused. I saw accuracy 92.9, then I saw F1 and recall 1.0. Were they different values, or is do you get
The
that?
reason being, sorry?
Yeah.
I'm sorry, did I cut in between?
Don't worry. I said I just wanted to know why they're different, like the accuracy and the F1 score. I believe the F1 score should be more truthful about the accuracy dance, the accuracy itself. If you get what I mean, like the F1 and the recall should be a better metric in this case than accuracy.
The reason for our data set is that we first used logistic regression because it was a classification problem, but it's not giving really good results because the elements that we had dropped were found out from correlation analysis or something like lasso lasso specifically for classification. But when we leveled up to XGBoost, like extreme gradient boost or light gradient boost, something like that, LGBM and XGBoost, they have a tendency of building their own random forest, which goes level by level. So they do the correlation analysis themselves, and the parameters which are not important do get dropped in the way. So the models built with XGBoost and LGBM were actually better, but yet we preferred XGBoost because LGBM is mostly for a very, very big data set, which was not in our scenario. So we thought that using something which requires high computational power is not required, so we went for XGBoost. And that is the reason the equivalence scores are also different.
All right. Thank you very much for the explanation. Very good presentation. Good luck. Take care.
Thank you.
Yeah, thank you.
All right. Thank you very much for that nice presentation. Thank you, Hakim, for those nice words. Moving on to the next group, we have Team Tableau. Philip, Nathan, and Bidemi. Are you here, Team Tableau?
Yes, we are here. Nathan is here to present the group.
Okay, you can start sharing your screen.
Okay.
All right, your time starts now.
Okay. So, good evening. My name is Nathan, and then I'm going to represent the team Cybersecurity Risk Analysis. That's the team Tableau, who talking about cybersecurity risk analysis over the United States. So before I proceed to give more details, it would be good to come to know the active members of the group. So these were the people who actively participated in this research. We have about roughly 8 persons. So going straight to the problem at hand, trying to analyze the cybersecurity risk analysis, we first of all try to establish the problem statement. Or before I talk about that, let me talk a little about the data set that we used. Actually, we got our data set from Cargo. That was exactly where we got them from. The data set has about 5 different data sets. Each of them has a number of data in them. So we noticed when we did a kind of pandas profiling that the data are almost the same, checking them by their ID. So it's just a repetition of different sets of data. It's just that a different data set has more information than the other. So we said, okay, the best thing will be to merge all the data. So at merging the data, we noticed that we have about 860 unique identifiers. That is a unique IDs. Then we noticed that there are about 3,984 columns, and then about 16 rows, and then about 16 columns. Now, in these 3,984 columns, there were lots of repetitions, lots of duplicates. So we really had to do a lot to work on the data. So having introduced the data a bit, I will still talk about how we cleaned it. But then the main problem that we tried to solve in this particular project was to analyze this data and present them in such a way that someone can actually gain insights and make a data-driven decision in terms of knowing how to avert risk and mitigate some of the cybersecurity risks that were listed in those data sets, or that were common in the United States, according to a CISA known exploited vulnerabilities catalog for 2022. So come to say that about 3 aims were actually stated. Okay, I've highlighted them, but just for emphasis, generate meaningful insights on vulnerabilities and to identify potential risks and threats, offer recommendations and actionable steps to mitigate identified vulnerabilities, enable organizations and individuals to take proactive measures to protect their networks. Yes, so that's exactly is it about the aims and objectives. So we decided to clean the data. After cleaning the data, we got about 622 unique identifiers. It reduced from 860 as was earlier explained. We removed one column of notes that had just one row with value because the column was just not needed at all. So after that, we had a clean data set, and then we proceeded to work. So we did some further cleaning on data, further data processing and transformation of data. For example, the date time, we decided to extract some information like days of week, and then months and years from it. We needed that information in order to gain some insight of how the vulnerabilities came over time. So we decided to use a visualization tool, the Power BI, to gain even more insight from the data. And then we came up with this particular live dashboard that it's been seen here. So a lot of things were discovered. When we transformed our data, it's also good to know that the raw data came when the complexity column just had a high or low. So in order for us to gain more insight, we decided to transform them into low for 1, 2 for high. So looking at this, you can see that we have an average of 1.09. So in all, we can say the data were not as complex, even though there were many to handle. So on average, just a little above low. That is it. Then the severity, we had a low, we had high, medium, we had high, we had critical. So we decided to also transform the data, taking 1 for low, 2 for medium.
Sorry, you have 30 seconds more.
Okay, 3 for high, and then 4 for critical. And then we also discovered that the severity is a little above high. So looking at this, we got a lot of information that could help someone to make nice decisions. For example, looking at the source of the vulnerabilities, you see that the network was the highest source of vulnerability during this period, followed by the local system, and then finally the adjacent networks. And then over time, we also noticed that the actionable insights recommended in that particular data sets were actually very effective. If you look at this, you see that from first quarter of 2021, we had about 281 vulnerabilities, but as at July 2022, just 1 vulnerability was noticed, meaning that all the actions were actually very, very effective. So just to quickly summarize, we actually came up with this. I don't have more time to explain all of this, but the summary is that we have some correlations, basically between the CSV scores, the severity levels, the relationship was actually high. So we discovered that vulnerabilities added earlier dates were more likely to have higher severities. And then certain categories or groups, they have to have a very high severity more than others. And then some vulnerability with a higher complexity levels, they are more likely to have higher severities. Then vulnerability with higher CVS scores, they tend to require less complex actions to address them. So all of these were some of the insights we gained from the data sets. Then we fixed the highest challenge we fixed in this.
Sorry, the time is up. The time is up. Sorry. I had to add more time. The time is up. Thank you very much. Thank you very much for the presentation. Ayana, do you have any contribution or questions for the thing?
Yeah, I want to hear the challenges that you faced.
Okay, fine. So the highest challenge that we faced was actually handling missing data and then understanding the data sets. We had 5 different data sets. We really had to look into the data sets. It took us, in fact, I think that took us the largest time or part of our project execution time, trying to understand the data, trying to understand why the 5 different data sets were given to us, and then having a lot of missing data, a lot of duplicates and all that. So that was the highest challenge that we faced. We were able to handle it. That was it. So we'll recommend that next time, perhaps people who are collecting this kind of data should be more careful so that we don't have problem with a lot of missing data. Cleaning the data was the biggest problem we faced.
Okay, so I'm a bit unclear with what this project achieved exactly. I'm not sure I get exactly what the goal and what's the result of the analysis ended up producing. So can you expatiate on that? Were you the only person that worked on this?
No, I wasn't. We worked in a group.
Okay, so but you're the only person representing the team in this presentation.
Yes, my colleague that's supposed to present with me, I believe he had some challenges that made it inevitable for him to.
Okay, that's fair. Please go ahead and explain the goal of this project.
Okay, the main goal is to analyze the data sets so that someone can make good decisions based on the analysis presented. Let me show you an example.
All right, go ahead.
Yeah, for example, looking at this particular bar chart, you will see that the network is the highest source of vulnerability. So someone who has seen this analysis will be very careful and know that once he's on the network, he is most likely going to be exposed to risk, and then he will be more careful. So if it is possible, work with adjacent network instead of on the network instead. Okay, the local is more like on the middle. So there are still others that we have also checked. If we look at this closely too.
Okay, so yeah, there's no need to go further. I want to look at there's a visualization there I want to take a closer look at. Can you go back to where you have all of them displayed? Okay, so the vulnerability occurrence by quarter added, right? You said that the recommendations, the actionable insights by, you said something about actionable insights, right? Recommended were effective. Can you expatiate on that, please?
Yes, I was saying that if we look at this particular, it's actually a funnel. If you look at this funnel closely, you will see how the number of vulnerabilities reduced over time. As at 2021 November, that is the fourth quarter of 2021, there were about 280 vulnerabilities. But to see that it reduced, and definitely it's as a result of the required actions recommended, such as updates or patches, make use of antivirus and all that. Then you see it increase a little again.
Okay, so these insights were in the data set that you worked on?
Yes. It's from the data set that we worked on that we generated this insight. Showing that.
No, I mean the insights that were adopted by these companies were in the data sets that you worked on.
Yes, they're in the data set. They are.
Okay. All right.
They're in the data set.
Okay, so your own actionable insights from this project that you worked on, what are they?
Okay, looking at this particular one, we can see clearly that the required actions are effective. So if someone could go through that data set and he sees any of those vulnerabilities, he can actually apply the required insight recommended in that data set, because obviously they actually worked to reduce the vulnerabilities over time. So July 2022, we have just one. So that particular insight can actually help. And then looking at this.
Okay, so did you, sorry, I'll interrupt you, sorry, because to save time. Did you make any investigation into the spike in 2020 quarter I mean, the one with 147, right? So you said it kept reducing, but then we have a spike that quarter. Any investigations into why that was the case?
The data did not explain why. We depended strictly on the data sets to make all of our decisions. So the data did not help us to see why there was sudden increase. But from the data sets, we just saw that there was sudden increase, and that is it. So looking at them by quarter, we can also see how they reduced over time.
All right, that'll be all from my end.
Thank you.
Okay, thank you.
All right, thank you very much, Iena, for the elaborate question session. Moving on to the next team, this will be our penultimate group. We have team TensorFlow. We have Emmanuel and Cynthia from team TensorFlow.
All right.
We can't see your screen yet. Yeah, we can see your screen. Your time starts now.
Hello everyone, I hope I'm audible enough. My name is Cynthia and my co-presenter is Usiala. We are working on the data set foreign exchange rate prediction. Let's go to our problem statement. Problem, can you hear me?
Yeah, we can. Please go ahead.
Okay, let me just continue. For the problem statement, our problem statement was understanding and accurately forecasting the foreign exchange rates, which is crucial for stakeholders like businesses, investors, and policymakers. Our project aim is to analyze the China 1 per dollar exchange rate.
Please, sorry to cut in. Your slides are not moving. We can only see the first slide.
Emmanuel, can you change that? Or maybe you can stop sharing. Maybe I can share.
It's only showing your first. It's only showing your first slide. It's not moving to another slide. Mind you, your time is moving. Time is counting. Stop sharing, then reshare again. Yeah, to stop.
Emmanuel, let me share the slides.
If you're having difficulties, can we move on to the next thing, or you're ready to present? Okay.
So I'm sorry about that.
You have less than 4 minutes.
Okay, my name is Cynthia and my co-presenter is Isola. We're presenting the TensorFlow team. Our data set was on foreign exchange rates prediction. Our problem statement was understanding and accurately forecasting the foreign exchange rates, which is crucial for various stakeholders like businesses, investors, and policymakers for economic growth. Our project aim was to analyze the China $1 exchange rate by identifying patterns like trends, seasonality, and security. The main objective is to develop a functional model that can forecast and evaluate foreign exchange rates of any currency. The existing solution for a time series model, that was regression, A and M support vector machines, deep learning model. The approach we used was we restructured our data set for time series analysis. We selected 3 common models for time series, and we chose the one that had the best performance, and also created several functions for code reusability for different currencies in the data set. Our data set, we acquired it from Kaggle, which was generated from the Federal Reserve download data by Bruno Luis. The data set was on foreign exchange between the year 2000 to 2019 and had 22 different currency exchange rates, such as the Australian dollar, the British dollar, and the Canadian dollar, among others. Emmanuel, you can continue.
Okay, all right. So the data language is equated to random function, which enables us to execute and stuff. So
Emmanuel, sorry, you're not very audible.
All right. Can you hear me now?
Yeah, it's a bit low.
Okay. For the data ranking related to the random function, I use us to input count and currency. So we place data, and in terms of doing data analysis, so that the missing factor, we have one data 98 missing value. So we had to do it with basically one, and we use all two methods to do it. This next. This is what our data looks like when we input our cloud patch, which is what we're doing. When we currently we want to use experiment, we want to patch it. Next. Okay, for the ETA part, the line that shows the China yuan dollar trade over the US, while the bar chart shows the minimum announcement bracket of yuan by US over the US, which is 20,000 to 2019. Okay, for linear regression, we have to check the linearity. The relationship between value and linear shows that the straight line is linear destiny. So also, linear regression is affected by outliers. So we have to check if there are any outliers in our data set within construction, or there was no outlier. So after seeing the data set, we have to test and use different performance inputs.
You have 30 seconds more.
Which is the mean absolute error, the RSS, root mean square, and out square. So you can see that our white function according to white trend. So which means linear regression actually is well. Next. So we put it under one section for operators with the arena. Then it gives us a series. Next. Next, please. So we did from our details, so we use that as long as you guys follow the canonical account showing stationary truth, and this program plus follow the normal distribution. Then for our operation for this value, which is P because of the time, it shows nothing different. So we try to train our model, then you see that in the left position, the figure of the speaker and show that the time is nothing. So we did a lot of code vibration. So next is for our work code vibration, we can see that our web prediction follows the right test, and the automatic was far better than the one we showed earlier. So we move on to animal models. Next. So for animal models, we also check for the final procedure and the result procedure, what is the number distribution and predictive strength was low. There was no predictive strength when we use physical to find and create large value of 0. Next. So our model results for linear regression to see the AR model and although ARIMA had a slightly better performance than the regression, however, due to its high runtime, we selected linear regression for this because of its faster prediction rate. So we created a main prediction function which allows us to just input the currency and the currency that we want to predict. So you can see architect price for the one when you get a currency value of 8.797. It was a value of 27.
Sorry, your time is up. Sorry, your time is up. I have to add more time for you. Thank you for your presentation. Ohakim, do you have any question for the team?
I want to understand like foreign exchange rate, like different currencies or just one specific currency.
Okay, we're using different currencies, about 22 currencies, but we used China. Because we give the
You're not even audible enough. I can hear some echo at the back.
Yes, your voice. Just try and speak more. If you're using an earpiece, if you're using an earpiece, just remove it and speak directly to your system. Because we can't hear you clearly.
I'm doing that right now. Okay, for the data set, you were given 22 other currencies, but we use China the one as a case study.
Okay. Okay, so just China the one that you use study.
Hello.
Hello, can you hear me? How did you do your train test split?
So I did not get that.
How did you do your train test split? Your train test, like I can say X test, X train. How did you split them?
Okay, we split them using 44. So what we did was we checked for the length value of X and we used 80% for it. So we got the integer in form of 20%. That means we split and transferred to 80%, to 20 to 80% and just so the first 80% was given to our X train and Y train, so X and Y. Then the last 20% was given for X train and Y train.
All right. Yeah, that's good. That's good. So do you know why you did that?
Yes, sir.
Why?
Okay, the reason we did that was because for time series analysis, it follows date, just in sequential order. That means 3rd of March, 4th of March, 5th of March, 6th of March. So using a random split, 12 split would actually just give us a random value. That means putting data from March, putting data from April, just randomly like that. So that was why we got
Okay. I can also add that you did that because of something called data leakage. It's just like you want to forecast the future, but you are taking future data, like your model is not seeing the future, like your model is cheating. So that's why I'm just adding like for reference that's why you are splitting with time and you're not putting the future or doing random splits. Do you get what I'm saying?
Yes, I get what you're saying.
Okay. Nice. Okay. I just wanted to add that there's something called data leakage, and that's why you have to split it sequentially, not random splitting, because of something like called data leakages. And you see that when you train like that, you have high scores, but when you actually put it to test, like real data, it doesn't work out. So did you try out other models, like apart from ARIMA models? Did you try out Prophets? Did you try out even deep learning models on this task?
No, sir. No, we only use 3 models, which is linear regression, ARIMA, and auto-regression. Even the auto-regressive and ARIMA, because the basis of workforce validation, it took a long process for the code to run. Because we have to keep iterating each value for Y test and getting.
All right. Okay, thank you very much. That was a nice presentation. Yeah. Thanks.
All right, thank you. Okay, moving on to our last team for the day, team Spy. We have Abdul Karim and Caroline.
Good evening, everyone. Yeah.
Right.
Okay, can you see this?
Okay. Yes, your time.
Good evening, everyone. Okay, good evening, everyone. My name is Abdul Karim from Team Spy. I, myself, and Miss Caroline Samuel we're going to talk about bank chunk prediction. Now, the topic of discussion, we have introduction, problem statement, process flow, the data set description, EDA, model training and evaluation, the conclusion and recommendation. Now, the introduction. Businesses like banks that provide services have to worry about problem of churn. That is the probability of leaving or discontinuing, probability of leaving a company or discontinuing the use of products or services. Churn have a significant churn has a significant effect on businesses and can lead to loss of revenue and can lead to decreased market share and increased customer acquisition cost. Now, the existing solutions, there are several approaches that have been proposed in order to address the problem. But despite the solutions, there's a need for a more accurate and actionable prediction models that can best understand and predict the retention strategies. Now, the problem statement and objective. The goal of this project is to identify the key factors that influence the customer churn in banking industry and provide recommendations to the bank on how they improve customer retention, compare different machine learning algorithms, and build and deploy machine learning models in order to predict. Now, our process flow, we have data collection, preparation, data preparation, model training, model evaluation, and model deployment. Data description. The data set we used was sourced from Cargo, and it contains information like bad customers, which include demographic information, account information, transaction history. The dataset has 10,002 columns and 14 attributes. Now we clean and preprocess the data by handling missing values, duplicates, encoding categorical variables. Now we remove the row numbers, the surname, and customer ID because they are unique to each and every members. The exploratory data analysis, we used histogram, box plots, count plots to visualize the numerical and categorical variables. Correlation analysis, the correlation matrices and heat map were used to visualize it, and the feature importance were used to know the best attributes. Now, for the exploratory data analysis, the proportion of the customer that churned and retained. Now we can see 79%, 79.6% are retained and 20.4% have churned. Now we can see that this diagram shows an imbalanced data set. So find a way to make our model in order to balance everything together by using smooth. So we use smooth synthetic minority oversampling technique. It's a popular technique used to address class imbalance in machine learning. And now, for the proportion of geography, we know that 50.1% are from France, 24.8% are from Germany, 25.1% are from Spain. Then for active members, 51.5% are active and 48.5% are not active. Now, okay, for the heat map, we can see that 0.29 correlation, age is like 0.29 correlated with the exited and so on. This is the heat map for it. Now the feature importance, we can see that its active member has the highest feature importance and the number of products, then followed by the age, the gender. Now, okay, for the model training, selection, and evaluation. Now, based on this scores and matrices, you can see that XGBoost has the highest scores in all the matrices, followed by random forest and all. Now, based on this XGBoost, now we can see that it has high correctness in classifying cases, a good balance between precision and recall in identifying positive cases. That is, the prediction are often correct, and a high proportion of the actual cases are captured. Strong overall predictive capability. Now, summary and conclusion, predicting customer churn is important for banks because it allows them to identify customers who are at risk of leaving and taking action to retain them. Now, this can help banks to improve customer retention, reduce cost, associated with acquiring new customers, and increase revenue and profitability. Future directions and research and improvements in customer retention should include using advanced machine learning models like deep learning and reinforcement learning. Now, recommendation based on the result of the analysis, we recommend that the bank will focus on improving customer service, offering personalized product and service, providing incentives for long-term customers, targeting high-risk customers, and improving the product offerings. And we want to move to the deployment. We deployed it using Streamlit. Now, this is the deployment page. Now, let's assume we have credit score to be 300 and geography.
So we can't see your deployment page. I think you have to reshare.
Okay, coming. Okay. Can you see it now?
Yeah, we can.
So the credit score, let's assume is 300, and the geography, they are from Spain, and the gender, let's select male, the age, let's assume 40 for tenure, let's assume 2, okay, for the balance, let's assume the person doesn't have any balance, and the product purchase, let's assume the person doesn't purchase any product. Okay, now does the customer have credit card? Okay, let's choose yes. And is the customer an active member? Let's choose no. In order to want to use this method to know whether our model can predict and can generalize everything. Now for the estimated salary, let's choose 5,000. Okay. Now you can see, yes, there's a high probability that the customer will churn. Thank you very much.
Okay, thank you very much for that nice presentation. Irene, do you have any question, contribution?
Okay, yeah, you started out talking about existing solutions. Can you take us to that page?
Okay. Yeah.
Okay, so how exactly does this differ or improve upon existing solutions?
Okay, now you say that there are existing solutions in order to note how a customer churn. Now you say that in machine learning, we due to data set we acquired before, we can use to train the model in order to accurately predict. Okay, now based on the solutions, based on the fact that other organizations have used in order to predict it, so we actually accumulate all the data sets in order to use to predict it, so that it will be generalized.
Okay, so you're saying that the data sets that you used was an aggregation of all data sets that
no,
typically address this.
No, it's just that.
Yes, go ahead, because I think that's what I got from what you said. But
okay,
go ahead and explain.
We collected data set from Cargo, and so when we checked it, it contains some cases which there are some cases whereby the members, maybe like they are likely to leave and to stay. Okay, cases like is active member, are they active, or do they have credit card? So those cases, when we are looking into all of them, we notice that some of those problems have been encountered before, and there are ways in order to bring out data set by collecting based on it, each and every one of them, they have been finding a way in order to solve the solution. And so in order to check it, then we compile every detail in order to accurately predict it in this case. So that's why we used Cargo data set. I hope you understand. Okay, let me just show you my analysis.
No, there won't be any need for that. Yeah, I understand the reason for your approach. Okay, so fair enough.
Okay. Okay.
Maybe I can help him with the question. I am his.
Okay, on second thought, I mean, you're already on the page, right? So go ahead and show me what you want to show me.
Okay.
Abdul, you wanted to show me the analysis, right?
Ma'am?
You wanted to show me the
Yes,
analysis,
ma'am.
right? Yes, go ahead.
Yes, ma'am. Yes, ma'am. Now, we noticed that the exited members from the old data set, they are very small. So now I now bring out the exited as a whole, exited data set, exited part as a whole, in order to see exactly why are they leaving. Now we take a look at the geography. Now, before we noticed that the high geography are from, I think are from Germany, I think so. But now the high geography is now from France. Then we notice that the gender, before the gender, those that are left are male before, like the old data set. When we look at the old data set at one, now we notice that before it was male, but now there is 55.9% people that actually exited, they are female. Now,
Okay, so
these are due to many other.
I'm going to cut you short, sorry. What companies were you particularly focused on? Sorry, this data set, what's the population it covers?
They are mainly on banks.
Scroll back to where you have the visualization for the geography.
Okay. Yeah.
Okay, fair enough. All right, that would be all from my end. No other questions. Generally a good work, well done.
Thank you very much, ma'am.
All right, thank you very much, Iene. Okay, you can stop sharing your screen now. Yeah, with that, we've come to the end. We've come to the end of our presentation. That was a very, very interesting presentation. Before we go, any final words for the intern, Iene, for each of their presentation? Any final words, any contribution, any recommendations you might want to give to them?
Okay, I would say well done on all the work that you have done so far. And I would recommend that you try to understand the reasons for some of the decisions that you make in the course of working on the project. It always makes sense to dig a little deeper so that you can offer viable explanations for the trade-offs that you make in the course of working on the project. Other than that, that'll be all.
Okay, thank you very much. That's nice words. At this point, I'd like to say a big thank you to all our presenters, the teams, and the judges, Iene and Oakim, for a successful session. Myself and the rest of the Hamoye team are honored to have hosted you on this episode of the Hamoye Premier presentation. Before we go, please take note of the following. That's for the intent. The results of this presentation will be computed and published on Slack in coming weeks. Also, stage C of the internship still continues, so we should pay attention to that to take more notes on the course contents and tackle the quiz if you are sure and you know that you can handle that. And also more announcements will be made on the Slack channel. On that note, it's a goodbye from me. Thank you everyone for joining. Thank you for the presenters. Do enjoy the rest of your weekend. Bye for now.